Hello and welcome to DevSecCon24. I'm Brian Clark.
And I'm Eric Smalling.
And we're your hosts for the Americas region of the conference. How you doing today, Eric?
I am doing wonderful. How are you, sir?
I'm doing wonderful as well. Even better now after listening to that little tune.
I know.
I heard you played a lot of the instruments in that.
Yes. In another life, another timeline.
You're so talented, man. I'm impressed. I really like the horns, and I'm a big fan of saxophone, and hearing that little going off in there, I'm loving it. Anyway, so how should we get everybody acquainted with the Americas region, Eric? What do we got in store for today?
Wow, what don't we have in store? We've got all sorts of good stuff today. We've got, well, I mean, if you're new to the platform, welcome, and know that we have a chat right next to us. So if you've got any comments you want to make, you can comment right in the stage or event. We'll be trying to watch both of those. If look for the sessions in the what I'm looking at the screen over on the side here. Go set up your agenda and your sessions. Go make sure you're getting into all the right talks.
Yeah, and that's all over on the Hopin platform. So if you're watching over on YouTube, that's fine, and that's good and all. But if you'd like to, you head on over to the Hopin platform where you have a little bit more access to things like the sponsor booths and some of the more navigation capabilities that Eric was just talking about, where you can set up an agenda, see the schedule a bit more detail, and add it to your calendar so that you can see what's going on, get reminders for those sessions that you really want to tune into. But I assure you, you're going to want to tune into all of them because we have a lot of great sessions in store for the Americas regions. But I don't want to say or create any competition or anything like that. But the past regions were fantastic, and I think we have a hard set to compete with. What happened there? Were there any that stood out to you at all, Eric, by chance?
Well, they say you save the best for last, and that would be us, right? I honestly don't have one that I can pick on top of the other ones. What about you? Did you have one that you liked the best?
No, I didn't. I'm not going to put myself in that position. I was more so putting you in that position.
I know. I see that.
This is what you get for hosting with me, buddy. But yeah, no, lots of excellent sessions that happened in the APJ region and the EMEA regions, and wonderful hosts that were hosting things throughout those as well. So shout out to all of them, and shout out to the team behind the scenes that have been putting on the conference thus far. Very sleep deprived, I'm sure, but they have put on a great conference so far, and we're going to keep that going in the Americas region.
I'm really looking forward to the keynote that Neelu is going to be doing with us. So she works at ThoughtWorks, and I actually am an honorary ThoughtWorks alumni because I worked with them so much back in earlier in my career, but I never hired on with them. So I always enjoy seeing ThoughtWorkers come in and talk. And I looked a bit at what she's going to be talking about. I'm going to be riveted and taking notes, I'm sure. Anything else we need to talk about before we get?
I think we can save some of this stuff in between sessions that we go on here because we want to stay on track. We don't want to get off time, right? Are you a pretty punctual person? Because I'm not.
Absolutely. Of course I am.
Okay, good. So you can keep us on track. All right. So I think without further ado, let's bring Neelu on to start up sessions there. Hey, Neelu. Let's unmute you. Hold on a second there. Neelu, feel free to unmute your mic in there.
Now can you hear me?
Yes. I'm getting a little bit of feedback. I don't know if that's just on my side. Eric, do you hear that as well?
Yeah, I'm getting a little feedback.
Can you hear me now?
Yeah, we hear you, but it's a little bit staticky. The mic sounds distorted a bit for some reason.
Okay, just give me a second.
Sure. All right, we'll give Neelu a moment to get that sorted out. In the meantime, we can catch up on some of the other housekeeping items that we wanted to share with you all. So we mentioned navigating through the agenda over on Hopin, the sponsor booths, right? So all the sponsors are running live events throughout the conference today. There's going to be extra content there, some giveaways at their booths. So head on over to the sponsor section in the Hopin platform so you can find that at the navigation bar to check them out and say hi. In addition to that, we have a Discord community, a DevSecCon Discord. If you want to find out and get connected with other developers, other security practitioners, DevOps folks, sneak people and everybody in the community to connect and learn more and level up your skills in this space, the DevSecCon Discord is a fantastic place to do that. In order to get the invite to join that, you don't have to do anything special, just the link to get there. If you go to DevSecCon.com, there is a link on there that says join the community, and that will give you the link to join the Discord. It says find us on Discord. So feel free to check that out when you get a moment. So let's bring Neelu back on and see if we got things sorted out there. Hey, Neelu.
Hi, can you hear me now?
Yes, fantastic.
Sounds
Much
great.
better.
Okay, great. So let me share my screen.
Sure. And I think what was happening there is your microphone, no pun intended, intentionally right there, but it was going full throttle, right? It was just overpowered and ready for your next session that you're going to be speaking to us about.
Yeah, I think I had to reset it a little bit, but can you see the screen now?
Yes, we have it. We're ready to go. And if you want to take it away, feel free to go ahead.
Thanks, Eric. Thanks a lot for having me here at DevSecCon. So it all starts a few years ago, actually, and I was just thinking about the entire subject that I wanted to talk about. A few years ago, when I joined my current organization, those days were the pre-pandemic days when we used to go around meeting people. So I was pretty excited. I went around talking to the tech leads, tech architects. I wanted to meet the heads of tech and security, and I was trying to understand at that time what is their one main problem statement that they were trying to solve, and that I could help with. And almost unanimously, everybody was talking about just one thing. The main ask was to make security more proactive, given that it was an agile development environment, and they wanted the teams to be enabled to do security on their own. And interestingly, having been from an offensive security background and having done security the typical way for a long time, many of us would sort of dread the idea of letting go, losing that control that many of us as security teams have. And that felt a bit out of place for me as well. But I kept that in mind. I came back and I was thinking of, how do we tackle this particular problem statement that was given. And I kept thinking about it while I was, into automation and doing assessments and other things. So one day I was just talking to someone, and they just sort of threw this statement on me while they were talking, and very casually, they mentioned culture eats strategy for breakfast. And this is a famous quote by Peter Drucker. And at that time, it was new to me. And it just struck me when they said that. And I was thinking about it for quite a while. And then I realized how true that is. So essentially here, what he's trying to say is whether you have strategy and tactics and they have their own importance, if you want to succeed at an organizational scale, culture is something that you need to focus on. So that is what stayed with me. But just for us to understand the rationale behind what we are going to discuss further, I wanted to also show you this other side, which is more logical to the whole thing. Is in the past few years, we've been seeing attack trends moving from the network side to the application side, and now the new attack surface is more like cloud, and it has moved to the supply chain, and we are seeing more and more attacks happening in this area. It could be because of changing technology or newer environments, or even the ease of provisioning systems and scaling them these days. But whatever be the reason, when you look at it a little more deeply, for example, if you just pick up the supply chain attacks that have been so prevalent these days, you will see that many or most of these have happened because of either, for example, insecure pipeline components or insecure product, or just unmanaged secrets. And the common denominator in all of this is that we as development teams have left something open or misconfigured or something like that. Now, the other thing that I was thinking about when I was thinking of this is that given that there is a lot of change, there are a lot of variables, there is something else that has changed as well for these kind of attacks to be very, very prevalent now. So, and that's when I thought about Agile. We have been working in the waterfall model for quite a few years, long time back. And most of us, or many of us, have in the last decade been moving to primarily agile forms of development. Agile, as many of us would know, is iterative and incremental. It's time boxed. But one primary thing about agile development is it is very fast paced. There are faster releases, there are faster deployments happening, and the context is evolving very, very fast. What happened in this last few years was that the speed of development in agile was so fast that operations had to catch up. They had to automate a lot of things, and I would say it worked wonderfully for them. But the idea is, can we equate that with security? Will it equally work for security? So when you look at the products which are available, now there are a lot of products in the market to do product security of sorts, but you can in fact do code reviews, you can do dependency checking, you can do dynamic testing, infrastructure assessments, or even container scanning. There are a lot of things that we can do. However, even in that attack surface, you will see that things like business logic issues, API security, issues around IDORs or session management, a lot of these kind of issues which are not picked up by these products. So I wanted to actually give you a quick idea of the extended attack surface that we are actually dealing with in terms of development. As it's a very rough sort of an indicator of what I'm trying to say, but you understand in terms of these are the components in terms of the agile development environment. You will have a developer who has who's pushing in the custom code to source control, and then there are a bunch of libraries that we pull in. We build that and create our container artifacts and essentially push that to production. Now, it's not just these systems. There are many other systems like at the back end, like the data stores or databases that you're dealing with, other public or private repositories from where you're pulling in your images. And these are not just these instances that we are talking about when we say development, particularly in Agile. We are also talking about all of these various actors who could be vulnerable or could be compromised in one way or another. That means the real attack surface is not just any of these components which could be vulnerable. In fact, I think there is a talk on CI fuzzing later today, which you should definitely watch. I will look out for it. Individually, there are a lot of vulnerabilities that we can exploit for these components, but there are also a lot that can be done for the actors themselves who are maybe configuring these systems, setting them up, or writing the code base. That means that there are a lot of other attacks that can happen as well. Like there are supply chain issues, there's social engineering, phishing, endpoint issues. And as you would remember recently, there were a lot of 0 days that sort of gave us a roller coaster ride. So those things are there as well. So that brings us to the other point, which is the other layer which we generally talk about, which is people. And people becomes then the center stage of if you are trying to make any long-term lasting impact in terms of security. When you talk about people in an agile development environment, the main set of folks that you will think of or who should be the centerpiece of your or the target audience that you have would be the development teams, right? So when you're mainly dealing with the developers or development teams, what is it that you're supposed to look at when you're trying to actually drive a mindset change for them? So essentially, first try and understand what are their development challenges. Many times as security teams, we forget to even think about it. They're already being agile. They're working towards faster time to markets. They're working towards performance indicators that they have to meet, usability requirements that they have to meet, and all of that they are doing in tighter delivery timelines. Then, before you go to them with a product for automation, it's important to understand what is their current tech context. Like, for example, how do they manage their dependencies currently, right? What is working for them? What is their process of PRs? And if you are going to introduce a process change for them, it's also important to see where they are in terms of, for example, awareness, to even pick up that process and make the right sense of it, and not just make it a checklist in their entire scheme of things. And hence, I came back.
I'm so sorry to interrupt, but I just wanted to give you a heads up that we're getting a lot of that static audio feedback again. So if you can potentially reset, and we'll just pause here for a moment.
Okay.
And try whatever you did last time to fix that audio issue. Let's try doing that. All right, just a moment, folks. We'll get the audio sorted out and continue on here. Thank you all for your patience. Appreciate it. Good to see everybody lively in the chat. Seeing folks joining from all over California, Arizona, Michigan, Florida. Hey, Neelu, welcome back.
Hi, can you hear me now?
Yes, and you sound crystal clear again. Let's hope it doesn't happen, but just a heads up, it may happen progressively over time. It seems like it's building up, but so I may pop in again. Just a heads up. Sorry about that.
Okay, just give me 1 second.
Sure. Southwest Florida, we got Toronto. Where else are you all coming from? New Orleans, Louisiana. Love to see it. Love to see it. Ohio. What else? What else? Spain. Thank you so much for joining us from Spain, Daniel. Tampa, Casey, good to see you. Welcome from Tampa. Denmark, Indiana, Colombia. Holy moly, all over the place. This is fantastic. Maryland, Quebec, Washington, D.C. Hey, Neelu.
Can you hear me now?
Yes, you're good. Okay.
Okay. Just give me a second.
Sure, no problem. I know how it can feel, so no worries about the technical difficulties and stuff like that. We'll get through it, and we can adjust timing on things too. Okay.
Cool, no problem.
All right.
So
I'll
just to continue where I left. Yeah, thanks. When I came back and started looking at, how do you drive that mindset change? It was something that I was looking at more from a people standpoint, and how do we bring about that cultural change? I started designing a security change program that would bring about that change. And the idea and goal for us was to actually have security champions in every team who would sort of catapult security into the projects and stay close and drive that culture change. So whenever you are in that journey as a security team, when you're trying to design a program yourself, there are some key considerations to look at when you're starting that. So the first thing is keep the problem statement in mind. Many times there are so many issues that we are dealing with that we get into rabbit holes. So you have to understand what is the problem that you're solving for and how relevant it is for your target audience, in this case the development teams, and what kind of outcomes you're looking at. Secondly, look at the stakeholders that you have. It could be the participants, the development teams themselves. It could also be, for example, influencers in projects, right? Who you want to work with to take this further ahead. Also the leaders in your organization and stuff like that. And finally, also look at basic things like tech stacks. What are the technical constraints? What is the budget you're working with? The timelines that you're working with. Things like, for example, timeline is not just delivery timelines, but also the time that the teams will have to invest in your program once that rolls out. Secondly, when you're creating a program, always keep in mind to make it lean, because you're doing it for an agile development environment. So, for example, in our case, when I started, we had this whole 9-step process to go through to the right outcome, and it did work for us for the initial pilots. But what we did was soon we came back to brainstorm and make it much leaner from that perspective, so that we could roll it out to larger set of teams, because we were to work with hundreds of teams after that. So we made it very simple 3-step process, including onboarding, where we would focus on awareness, workshops where we would focus on more practical high intensity tasks which we would enable the sec champs for, and followed by governance. When you're defining any process changes that you want them to pick up, the teams to pick up for your program, it's very essential when doing that for an agile environment is to align with the key agile rituals. That way is what happens is it ensures that it becomes a practice for them, and that it becomes more like muscle memory, right, when they're doing development. So in our case, when we had threat modeling like at the heart of what we were trying to enable them for. And for example, for iterations, right, we would have sprint plan or an initial iteration planning meeting. So when that ritual happens, we made sure that we are looking at the teams are picking up the features right at that time for which feature would be threat modeled, in that iteration. Secondly, rotate and iterate. So it's important to have frequent but smaller threat modelings in this parlance is to do it more frequently but in small sizes. So for example, rather than doing an entire threat modeling for an entire application, we would rather focus on smaller threat modeling on features but do it more frequently. Thirdly, make it official. Whatever threats that came out of our threat modelings are supposed to go to the project dashboard. So for example, your Jira or your Confluence, you can add it to that directly. Secure your source. So it's good to start with secure defaults. Create, for example, secure baseline images or hardened configuration or a safer code base to start off with. Totally depends on the program that you are going for. In our case, for example, we had, in terms of threat modeling, because that was at the core of this program, we were focusing on giving them an initial set of scenarios that they could look in the context of, which were generally the commonly occurring scenarios for our teams. And lastly, leverage the pipeline. So I think this has been discussed a lot and tremendously in DevSecOps. So I will not speak too much about it. It's important. It's a very special place in development where you can add and automate a lot of stuff. So leverage that, but ensure that you have the right kind of KPI set for it. For example, when does it really break the build? Or do you have the SLAs to go ahead and fix the high critical issues that you have found in that particular run? So before going in with it, we had the onboarding process where we're looking at awareness. But some important things to do when you're going for developer awareness is, apart from the general awareness that you're looking at, it's also important to look at role-specific trainings, in the sense that what can they do in their respective roles. So we know that a developer can code securely. A BA, they will be gathering requirements, right? So they should be explicitly asking for security requirements as well. And they should be adding that as acceptance criteria in their stories as well. So those are the kind of things that you want to tell them and how to do that, so that the security is everyone's responsibility actually becomes true. Secondly, there are many times that we create a lot of these baselines and checklists and even images and stuff that I was talking about, but many times developers may not have awareness around that. So do they know where it is? Can they just pick up and run with it when they are starting off their projects? Is something you should ask yourself. And lastly, look at a format of awareness where they can stay updated. There are so many new attacks coming up every day. Are they updated about these recent patches? Any recent issues that affect their systems? So things like that should be discussed very, very frequently. And one efficient way of doing that, we figured, was to create and nurture a community of all of these people. So we created a community of SecChamps where everyone, especially SecChamps and the development teams, could actually interact around more hands-on fixes and talking to each other about these daily issues, which they could then pick up and discuss with each other and resolve. In our case,
Neelu, I'm so sorry to interrupt again. I don't mean to keep doing this to you, but that static keeps creeping back in somehow for some reason.
Okay. Should I go back to that, or?
I don't think it's when you, yeah. Okay. All right, we'll let Neelu sort that out one more time, and then we'll pick things back up. But while we're at this little pause here, folks, a reminder, if you have questions, queue them up in the chat room, and we'll be sure to grab them and do our best to include them towards the end of the session to ask on stream, on the stage and on stream. All right, Neelu, you're muted.
Can you hear me now?
Yeah. Do you know if there's anything in particular that's causing it, or what's allowing you to get back to clear audio? Maybe we can help you.
This is because of the mic. I can remove the mic. Just give me a second.
Okay. All right. So yeah, get those questions queued up for us, and we'll get them asked towards the end of the session, and go from there. But hope you all are enjoying it. And again, thanks for letting us know, everyone, where you're joining from. It's really awesome to see, like, all over the world. So it's like both a blessing and a curse technology, right? The blessing is we can join from all over the world right now for this session. The curse is technology is causing some static audio issues for us, unfortunately. There we go. Hello?
Is this okay?
Yeah, I can hear you. Seems fairly clear.
Okay.
All right, let's go from there. If you want to share your screen again, we'll get that back on stream and go from there.
Cool.
All right.
So for us, we were looking at, so in terms of awareness, we were looking at agile threat modeling, and what we were particularly trying to do is, apart from the academic side of it, apart from understanding how to do strike-based threat modeling quickly, we were looking at how to operationalize this better. We were looking at essentially telling them how you can time it better rather than running into rabbit holes. We were trying to tell them or teaching them around getting together and adding their perspective when they're doing threat modeling. How do they prioritize issues? So once you have the threats out, how do you prioritize the issues and add them to your project dashboard? How do you turn them into either acceptance criteria or stories, and or tasks for that matter, and then add them to the project dashboard? So these were the practical aspects that we wanted to focus on, something that they could pick up, would be more hands-on for them, and they could pick up and do it in a more agile fashion. For communication, one important thing to understand is try and leverage as many channels of communication as possible. Emails, chat channels, create channels if there are not any. But in an agile development environment, what I have seen works best is the face-to-face communication. And that, I think, stays for a very long period of time. In the past couple of years, that has become really difficult. But even wherever you can interact with smaller groups, or pair with developer teams rather than just remotely or working in silos and just sending an email and forgetting about it. One thing to keep in mind as a security team is to change our own mindset before we go to the developers asking them to change the mindset. So in this case, focus on people interactions rather than set standards that you may have. Remember that to make the function secure, you will have to make security functional. So always go with a working solution. Third, very important, is to collaborate with the teams as much as possible. Sit down, pair with developers or pair with DevOps and all of these individual roles and understand what their challenges are. And lastly, adapt to changes in technology. Right? Technology for development teams is actually changing really fast. So we should adapt to technology as much as possible. How do you engage the developers, which in our case we were mostly looking at SecChams and their engagement? One thing that I would like to share is, rather than whenever we go to the team, sometimes we make that mistake of throwing in security words or keywords or jargons. Like, for example, rather than telling them zero trust on the first day, it's always good to start off with discussing more concrete and actionable tasks, or items that they can take up maybe before their next stand up, something like that. Secondly, keep them motivated as much as possible, and aware of the recent issues. One great way of motivating these set of folks is to let them own their journey, right? Let them own the changes that they want to make in their projects, be it automation, be it around adding some other controls in process changes and stuff like that. Once you have told them what the goal is, let them own that. And lastly, you can also gamify the experience, right? So across your organization or delivery organization, if you're looking at engaging these people or all the development teams way more, it's always good to gamify that. How can you do that? Maybe you might have heard of the systems of badges or levels, different levels in security. So it's always good to create something like that where they can move from one badge to another and always look forward to something new. So that sort of brings in a healthy competition as well for them. So rather than giving them a one-time solution, it's rather good to teach them how to fish. That's the idea. So all of this works well in a smaller scale, and it worked well for our pilots also. But when you move on to address this at scale, like with, in our case, it was hundreds of teams that we were going to roll it out, I have some more learnings to share. First thing is simplify the goals as much as possible so that everyone, including a developer or a leader, understands it equally well and everyone is on the same page. That way it becomes very easy to interpret solutions that you are recommending as well. Atomic success is very important before you get success at scale, which means that if you're introducing a process or practice, always try and test it on some of the teams. It has to succeed in a unit scale. So whether you're looking at unit being your project or it being your squad or streams, it should succeed there and work well there for it to function well at scale. Thirdly, having a set of secure defaults really helps. So whatever be your program that you're building it around, it's good to have a set of secure defaults to start off with. Now, what it really helps with is to give that a quick win to the developers also. And once they have that quick win, it's like a win-win situation where they can start psychologically at a stronger place and then just stick for a longer time to the changes that you might have recommended through your program. The other thing that is important while doing that is remember what you are in for. So you are trying to drive a mindset change, and it's very important to build a mindset for edge cases. So essentially take them through that entire journey that you will have as a security person, right? If you were playing all of these roles, you would ask yourself questions or try to answer some of those security questions. Are they asking those questions? Do they have a critical mindset while they are playing their role within the development team? So that is something to look for. Leverage automation wherever possible. Once they start identifying threats early on in the life cycle, they will start seeing more uh, things or issues that can be predicted early on and or are recurring and can be automated. So for example, if there is a solution to add stages, right, to a certain type of pipeline, and you're dealing with multiple different kind of CIs in your environment, then what's created for one can be reused for another always, depending on how many different teams are using that. So leverage that as much as possible. When you're introducing processes or practices, it's important that they're effective. So the first thing to ensure that is that you align with your agile development lifecycle, the delivery timelines, the lifecycle, and the rituals, like I was talking about. And when you're adding practices, ensure that they're effective and they're driving a behavior change. So if you have an option of two processes or two different ways of doing something similar, it's always good to bank on the one that will drive the behavior change in the long run. And lastly, communicate the why. I think this is something that I cannot emphasize enough. I realized this only when we started addressing this issue at scale, and then we started working with hundreds of secjams. The initial part of clearing the why becomes or helps you way longer in the program or until much later. For us, this is an ongoing program, and once this why part is clear for all of them, all the stakeholders, there are much lesser questions and there are way more solutions. So the overall attitude of your target audience will definitely improve and become way more positive if you have clarified the why for them. So some of the results from what we had done earlier for this, we started with a pilot, a bunch of teams, and then we started doubling up on how many teams we wanted to roll this out to. Some of the early wins for us were essentially discovering hundreds of threats. We soon started discovering hundreds of threats alongside the secjams and the development teams, and also fixing the high critical issues from there. SecChamps soon became the point of contact for security, and everybody started reaching out to them internally and externally for anything to do with security. So now everybody had become way more proactive. And one of the things that definitely changed for us, which was not the goal of the program, but was quite interesting, is that the entire push model that security generally struggles with became a pull model. So initially, we would reach out to teams for them to enroll for the SecChamp program. And as of today, all the new teams that are coming up, they reach out to us directly to enroll for the program themselves, or even for that matter, for doing a threat modeling. So they would loop us in when they're doing a threat modeling, or let us know that how many issues they have and what are they prioritizing. So that makes the job of, if you have been a security team, that makes your job much, much easier than working in a push model. So in an ideal setup, how the people will play a role in the development would be something like this, where you are going through, ensure that the development teams are going through their role specific awareness, but also the tech stack specific trainings, because before you start development, you generally know what is the kind of tech stack that you're going to work with. When you're in the design phase, leverage threat modeling to identify threats early on, but not in silos or not only with a security expert, but the entire team should be involved along with your SecChamps if you have any. Once you have your security backlog created, ensure that all of these security acceptance criteria or stories or features that you may have discussed are moving to the project dashboard, and you allocate the developer a dev pair or a bandwidth for that to address that issue. Once you start development, definitely leverage automation for everything, including SAST or DAST or your container scanning and things like that. But towards the end of it, take time to have sort of a retro, like reflect upon or inspect upon what are the issues that you got from the threat modeling that you did, or from the automated runs, or even, for example, if you're doing an external vendor assessment, what are the kind of issues you're getting, how many of those are really recurring, which can be coded, right? Or can be coded into security unit tests, for example, or can be addressed through design or through acceptance criteria in your future stories. So for a mature security team, it will mostly look like this, where they are, it's much easier for them to get into security huddles, like huddles in the sense you can just pick up a feature and start looking at doing a quick threat modeling, or checking the workflow for security threats. Iterative threat modeling become a common thing. When you're defining the acceptance criteria for your stories, it should show the security validations essentially should be showing in those stories as well, which can be tested later by a QA. Of course, leverage automation as much as possible and add security to the definition of done. Right? So a story is essentially not done until it's security done. Finally, focus on the process and pipeline to ensure that you can gain velocity and ensure coverage when you're trying your change program. Understand that the ecosystem should be secure by design rather than the individual components in your supply chain. And lastly, leverage culture to add security to your organizational fabric. So there'll be many things that you might do to bring in smaller changes, add controls in place, have automation in place from time to time. But if we are driving the mindset change, it's better to play the long game. Thank you.
That was excellent, Neelu, and a round of applause for dealing with all the technical issues too there. You handled
Sorry
it
for
very
that.
smoothly, so I know
Always fun
how
to do it live.
yes. I know how jarring that can be, and you handled it so professionally, Neelu. So well done on that, and thank you for that excellent session. So I think if you have a few more minutes here, we have a couple questions for you if you don't mind. Does that sound good?
Sure.
Okay, great. All right. So first question that came up was, I believe it was Kavitha over in Hopin. Thank you, Kavitha, for the question. And their question was, what tools were used in the process journey? Or were there any in particular that you could call out and share with folks that enabled some of what you learned and shared through this process?
So for us, when we were driving the SecChamp program particularly, so we have other automation specific programs where we have tools which we recommend, for adding controls. Because this was mostly a people focused program and we were looking at agile threat modelings. That is a framework that we have sort of created within ThoughtWorks, and that's what we used. Particularly for agile threat modeling, it's based on top of Microsoft Stride model itself, but a faster and much quicker way of doing it. We did not use specifically any tools. There are tools for threat modeling as well, but given that our organization is more like a service-based organization, there are multiple clients and different tech stacks, different compliance requirements. The context is entirely different for all the clients. So we kept it simple and we kept it agile.
Excellent. The one thing that hit home for me, and we have a couple more questions, but really quick, one thing that hit home for me was when you talked about security as part of your definition of done. like it really brought me back to recalling some of my earlier developer days where we as a team were defining this definition of done, and we didn't have security included in there, honestly speaking, but we had things like testing and like like deploying it in a staging environment to make sure it works there. And so yeah, thank you for sharing that part in there. And like I'm thinking back, like how did we not think about, okay, how do we include security in that definition of done too? So it's just awesome to see, and I think this is gonna be super helpful to the older me as well, and folks that were there. So one more question I think we'll take real quick, and that is, were there were separate projects created for cloud and on-premise applications throughout this?
Um, we were essentially working on a security change program, and we were not delivering any projects. However, we were dealing with, if I understand your question correctly, correct me if I'm wrong, we were dealing with various projects. Some of them were on cloud, some of them were on-prem, and in fact some of them were also purely infrastructure projects, right? So the agile threat modeling, or for example for us it was threat modeling, we were working on. When we talk to about threat modeling, it would be different for example specifically for applications or just web applications or mobile applications, right? Because you look at different issues which are commonly found in mobile rather than web. So web would be different, mobile would be different, infrastructure would be different, because then you might actually do an infrastructure threat modeling, and also architecture review from that perspective. So this context was different for us, and with cloud we would definitely have or look into different scenarios for cloud. So that was the degree of difference that we were following. Within that also there were many subdivisions, but we didn't go that far. We wanted to keep it simple so that everybody could pick up and understand. For example, if you are looking at mobile, then you should go for also mobile top 10 issues rather than just blindly looking at the web top 10. So just giving an example from OWASP, there are very contextual issues to look at, and that's what we were focusing on during our threat modeling.
Gotcha. That makes a lot of sense. And thank you everybody that was posting some of the questions in there. Eric, do we have any more questions maybe that are coming to mind for you, or?
Yeah, well, Simon asked one. I was try to find it in our list. I'm just going to ask it from the chat.
Okay.
It says, when you say iterative threat modeling, what triggers an update to the threat model that was created before? Would bug fixes or minor improvements count?
Yeah, that's a good question. So when we say iterative threat modeling, it is to pick up a bunch of features, right? So when you start developing your services, you would have certain features being added with every release. Generally, it will not all happen at one go, like it happens in waterfall. So when you have a bunch of features which are being added with in every iteration, or every couple of iteration, you will have a bunch of new features coming up. We would pick up a bunch of features and then start whiteboarding and threat modeling around it. And that is what we call iterative, because it would be every 1 or 2 iterations we would have a threat modeling, because we would have new set of features that we would threat model on.
That's great. Great way to keep things fresh as the application changes. One of the things that actually I'm going to steal this. I'm going to quote you on this one. I loved when you said that you need to hopefully I won't butcher this. To make the functionality secure, you need to make security functional. That is like a genius quote, and I love that. Thank you so much.
Yeah, you realize so much of that once you are on the agile side of things, that but just to add to the previous answer, I think, just to clarify it further, if you've already done a threat modeling for your entire application or your entire service, for example, and you are then making a change, whether it's a bug fix or it's an update, you will have to look at functionally what you have really added. Sometimes minor enhancements we should not go to that depth, because then that makes it too much to a micro level, and you may not end up getting too many threats. So when you're looking at the ROI, because you're also counting time of how many times you're getting into a threat modeling, it's good to see what is, if it's a major change that you have done, a major update that you have done, if you have something majorly functional that has been added or changed, to go about doing another threat modeling for that change.
Very cool.
Excellent. Well, thank you, Neelu, so much. This was super insightful, and you did an amazing job. We appreciate you helping us kick off the Americas region for DevSecCon. and we'll hope to see you again soon. We'll see you in the chat, maybe over on Hopin and YouTube.
Thank you. Thanks, Brian. Thanks, Eric.
Thank you.
All right, folks, let's jump right into our next session. What do we got in store for everybody next, Eric? Do you know?
Next session is on CI fuzzing with Jonathan Metzman. And this is actually very timely. I was just watching, when I was at KubeCon, I was looking at fuzzing, testing, automation, and things like that. So I'm very curious to see Jonathan's take on this.
So fuzzing is like, well, let's get Jonathan in here. I got to know. Hey, Jonathan, good to see you.
Yeah, good to be here. I'll go over what fuzzing is, so don't worry.
Okay, because I'm thinking like stuffed animals. They're fuzzy. I don't know. I'm silly.
It's a lot to do with it. Yeah.
Oh, really? Okay, good. I'm on the right track. Well, without further ado, I'll let you take it away, and thank you for joining us.
Yeah. So as I was introduced, my name is Jonathan, and today I want to talk to you all about CI fuzzing from first principles, meaning I want to go through sort of like the history of fuzzing and how it went from like a tool for shadowy hackers into something that's just useful in any developer's like toolkit. Just a quick background on me. I've been at Google working on fuzzing for 5 years almost. First on Chrome's security team, and then on Google's open source security team. Today, though, I'm just only like representing myself, not my company. So some background on what fuzzing is. So fuzzing is a process, automated process where you take randomized inputs and feed them to a program in order to find bugs in that program. And typically these bugs are crashes just because, crashes are just like the easiest way to tell that there's something went wrong in a program. It's not application specific. And crashes are also pretty interesting from a security perspective when dealing with C and C++ programs. So in addition to possibly being denial of service issues, crashes could mean that there's like sort of memory corruption going on. Like, if there's a seg fault, perhaps maybe like, a more skilled attacker could use it to gain control of the program counter. So fuzzing has really been thought of as like a security technique, although it's also good for finding, sort of other like stability bugs. Now, it basically works by similar to how this like snippet I have on the slide illustrates it. You just basically, in an infinite loop, create a new input and pass that input to the code that you want to test and just watch for crashes. Now, fuzzing, if you were to like have just like a generic mutator that just flipped random bits and you were fuzzing something like a PDF reader, you probably wouldn't get very far into the PDF reader just because, it'll reject a lot of your inputs as invalid. So typically at this stage in fuzzing, people would write format aware fuzzers that just are basically right. They're aware of the format that they're targeting. And so like if we were fuzzing like a PDF reader, my PDF mutator would know about PDF files, and it could do things like add pages, remove images, add forms, stuff like that, rather than just like more like primitive operations like bit flips. But this is obviously like a huge pain to do. Like in order to do that, you probably have to read like the PDF spec, which as someone who's done that, I could tell you is not very fun. And, like we just want to find bugs. Like we don't want to spend our time doing this. So at this point, really, fuzzing was just like a technique used by highly motivated individuals, which really just means like attackers. So around 8 years ago, though, there was a big advance made in the fuzzing world called coverage-guided fuzzing. And this was pioneered by tools like AFL and libfuzzer and really helped shift fuzzing left, and that, it could become a tool that's accessible to ordinary developers who aren't maybe highly motivated, but are just like somewhat motivated. And so these fuzzers have mutators that are generic. Their mutators do things like the bit flips and, changing the values of ASCII integers. But the coverage guided magic is what allows it to actually effectively fuzz. So after each iteration, or execution on a test case provided by the fuzzer looks at what parts of the targeted code were executed. And if anything new is executed, it adds the test case that it just created to this list of test cases called like the corpus, and it for further mutation. And so you could see how like after a couple rounds of, this, we found some new behavior, then another new behavior, then another new behavior, that we're getting deeper and deeper into the program. And so this really and with infinite time, like you'd cover the entire state space of the program. So this really made it easy to fuzz without having to spend lots of time, writing like custom mutators or generators. And another development that really brought fuzzing into I'd say almost like the mainstream of just like software development was the birth of just sort of fuzzing infrastructure. So I'm most familiar with Cluster Fuzz because that's Google's fuzzing infrastructure, which was made around the same time as AFL. And what it does is it automates a lot of the sort of tedious work that you would have to do around fuzzing, such as checking that your bugs are unique, because fuzzers do execute thousands and thousands of test cases, and you'll probably get the same crash many times. And so you're going to want to root cause that and not look into each of those separately. Crash minimization. Just you can take my word for it that there's a lot of tedious steps that you would have to do as a developer fuzzing on your own machine. And ClusterFuzz pretty much automated all of that so that you could continuously fuzz, and all you would need to do is sort of write fuzzers and fix bugs. And the way it worked is you have automated builders that just continuously produce builds of ClusterFuzz was developed for Chrome. So, these builders are built Chrome and Chrome fuzzers. And it uploaded those builds to Google Cloud Storage, where it was then consumed by ClusterFuzz. And what I mean by consumed is ClusterFuzz ran the fuzzers, and with any crashes, it sort of triaged them, automatically filed bugs against developers, and then every day would check that the bug was fixed. And if so, it would close the bug. And so, as you can see, the only manual steps are these sort of writing fuzzers and fixing bugs. And this workflow worked really well on Chrome. And we extended it to other parts of Google, like Chrome OS, Android, internal code. And it's very tailored towards what we can do as Google, right? So, we run ClusterFuzz on hundreds of thousands of cores. We run, probably in the thousands of fuzzers. And we found over 50,000 bugs that we've reported with ClusterFuzz over the years. And other big companies Microsoft has a similar tool called OneFuzz, which is basically their version of ClusterFuzz, right? So I think this model works pretty well for large companies, basically the companies that have people developing these tools, just because it's just very tailored towards the needs of the company. But if you're just an ordinary developer who doesn't want to think too much about fuzzing but wants some of the benefits, is this really sort of what you want or need? Are there costs to having such a fancy infrastructure? And of course, I wouldn't be here if there weren't. This fancy infrastructure is difficult to set up. It's pretty heavyweight, and so there's a lot of just different parts you have to set up. These infrastructures are not very portable. They tend to be written for the cloud of the company developing them. So, for example, ClusterFuzz doesn't run as well outside of Google Cloud as it does inside of Google Cloud. There's some features that you can't get. And I think the same is true for OneFuzz and Azure, Microsoft's cloud. And another problem, just with this approach that, in my mind, is that, it's continuous, but it's sort of not really continuous integration. It's being done after the point of integration. And, I don't think that's ideal, because a developer, after they've committed code, should be able to sort of forget about it and move on to the next feature rather than, having to fix issues in it that were discovered like a day or two later. Like that's never fun. And so I think just sort of the point at which cluster fuzz is sitting is not ideal for this purpose. So to address this problem, we spent a fair amount of effort moving fuzzing into CI. And to support fuzzing in CI, we wrote a tool called ClusterFuzz Lite. ClusterFuzz Lite can run in common CI systems, such as like GitHub Actions. And it's actually meant to be very portable to other ones. And what ClusterFuzz Lite does is it can fuzz your code changes, such as like your pull requests or commits, and catch bugs in them before they land, instead of fuzzing your code after it lands and giving you bugs like a few days later. And because it's lightweight, it's very trivial to set up and like port to other platforms, and just low maintenance in general. Even though it actually is using ClusterFuzz's code base underneath the hood. And just like as proof of it being like effective and easy to use is our users. Like we have, over like 100 users, mostly from OSS Fuzz, that are using ClusterFuzz Lite for finding bugs in their code, before they land. And, we found hundreds of crashes in those projects' code. And so the way ClusterFuzz Lite works is intended to make, fuzzing like you would run unit tests in CI. So pretty much like any other CI tool, this is ClusterFuzz Lite in GitHub Actions. You get like a pull request, and ClusterFuzz Lite kicks off fuzzing it. And if it finds a crash, it reports like a failed status. By the way, CI Fuzz was just like an old name for ClusterFuzz Lite. So it reports a failed status, and makes available the inputs that caused the crash for you to so you could reproduce it on your own, and lets you view the output of the crash. So like here's the stack trace from a crash that ClusterFuzz Lite found in OpenSSL, and this crash, or this bug rather, wasn't actually merged into the OpenSSL code base because ClusterFuzz Lite caught it before it could be merged. So hopefully I've sold you pretty well on ClusterFuzz Lite. Let's maybe dive into a bit of how it works, just because I think there's a lot maybe I could learn from sort of the DevOps community on what works well in CI, and maybe some people will like some of the compromises and trade-offs we made. So fuzzing is not like ClusterFuzz Lite was not as simple as just like plopping fuzzing into CI and calling it a day, just because fuzzing is sort of like ill-suited towards CI, I think, or at least like how fuzzing was done before ClusterFuzz Lite. Fuzzing, relies on like non-determinism. There's randomized inputs, and that's not great in a CI system because you want errors to be reproducible, so that devs know what they did wrong. Another problem is just like speed, right? So fuzzing may need, like, you never know really when you're done fuzzing necessarily. It's always possible that there are more bugs. It's not like a sound technique that like proves the absence of bugs. But we can't spend like hours. So, and you probably will find more bugs the longer you spend fuzzing. But you can't, we can't spend hours fuzzing on a pull request and block it from landing. Like, no dev is going to put up with that. And finally, there's an issue of like fuzzer selection that I'm going to touch on in a bit. So first, the non-determinism. There are two really bad ways that like non-determinism in fuzzing could really burn someone doing fuzzing in CI with like a naive approach. So if our fuzzers were non-deterministic in CI, what they could do is convince developers that they introduced a bug that they didn't in fact introduce. So for example, suppose Alice commits code on Monday that contains a bug. And because fuzzers are like unsound, it just happens to miss that bug. But later, Bob on Tuesday has a pull request up, and the fuzzer happens to find Alice's bug now. Well, like Bob is not going to be happy that we're failing on his pull request and not on Alice's. So that's one issue. And another one that's perhaps even more insidious is convincing you that you fixed the bug when you actually haven't. So the way this would work is, if, let's say, suppose that CI fuzzing were capable of finding Alice's bug like in her pull request. And then she tried making a fix, but the fix was incomplete. And she puts up the pull request for review again, and CI fuzzing kicks off. And this time, due to randomness, like it misses her bug. Well, to her, it's going to look like that bug was fixed. And so that's obviously like quite bad. So to deal with this, we do a couple different things. The first, like the simplest, like low-hanging fruit was just, using a fixed random fixed seed for the random number generator. And this kind of reduces the number of bugs that we find overall, probably, but it gives us more determinism, which I think is more important in like a CI fuzzing system than, completeness is not as important as some of these other properties. And then the other technique that we use is we only report novel crashes. So back to like the Alice and Bob case, what ClusterFuzz Lite actually does is if there's a crash in Bob's pull request, it'll download an old build of the fuzzers and see if that crash could be reproduced in the old build. And if a crash could be reproduced in the old build, then we know that the code that we're testing, Bob's pull request, did not introduce it. So ClusterFuzz Lite actually won't report the bug in that case. And hopefully, like if you're just doing that, you might end up like missing bugs, but hopefully you'll have another longer running fuzzing process that could catch that later. So that's for non-determinism. Now, speed is another problem, right? Like I pointed out that we'll find less bugs we'll probably find less bugs if we fuzz for 10 minutes rather than 2 hours. But, what do we do? So here I made the very scientific decision to fuzz for 10 minutes. And, of course, that's the balance of two goals of how do we get results back to developers quick enough versus how do we, find as many bugs as possible. And I think there's some anecdotal evidence that this like 10 minutes is enough. Some developers say that like most of their issues are caught by ClusterFuzz Lite before they even get to OSS Fuzz. And I've actually looked at like some data from OSS Fuzz, and there's data to support this claim too. About like 40% of new bugs that were found during fuzzing were found like pretty soon after the bug was introduced. And so there's actually a reason to think that this bug could be found faster on ClusterFuzz Lite than it could in ClusterFuzz. But yeah, there's at least like around like 40% of the bugs that we could find. If we could find around 40% of the bugs that we would find with this heavyweight infrastructure, if ClusterFuzz Lite could provide that and take like 10% of the effort and 10% of the cost, I think that that's like quite a big win. And finally, the last like smart feature of or like adaptation we made to CI for ClusterFuzz Lite was deciding which fuzzer to run. So fuzzers are kind of like chips in that like people who write one tend to do more than one. So here you could see like fuzzers in system D, and you can see that there's at least like 4 that begin with the letter B, right? And there are actually many more fuzzers, right? So how do you know, when you have like a pull request that you're testing, how do you know which one of these to run? And what ClusterFuzz Lite does is it will download coverage reports for each fuzzer, and it'll take the diff that it's actually testing and see, oh, this fuzzer covers the code that's been changed. I'll run that fuzzer, and if the fuzzer doesn't cover that code, then it doesn't get run. And so we can more efficiently spend the 10 minutes that we have to fuzz running fuzzers that could actually find bugs introduced by the change than we would if we were just running every single fuzzer. And ClusterFuzz Lite has a lot of like just features that ClusterFuzz does, such as like support for different sanitizers, which are good for finding different kinds of like issues in C and C++ code, like undefined behavior or use of uninitialized values. It also supports other languages such as like Rust, Go, Python, and Java. And I know I've sort of focused a little bit on C and C++, and that's just sort of where fuzzing has had the most success. but it's definitely a useful tool for non-C and C++ projects. Yeah, so in addition to providing like CI style fuzzing where we're testing code changes, ClusterFuzz Lite could actually provide some of the core features of ClusterFuzz. For example, like just long running fuzzing jobs that take multiple hours and like asynchronously reports bugs, which is just like the main thing ClusterFuzz does. That could be done by ClusterFuzz Lite using just like the cron functionality of CI systems like GitHub Actions. And another cool feature that ClusterFuzz Lite offers are coverage reports, which I mentioned before are useful for determining which fuzzer to run, but are also just nice for developers because they could see which parts of the code are being tested during fuzzing and which parts are being missed. So now hopefully, we have enough background to like understand what ClusterFuzz Lite does, and maybe some of you are eager to see how you can use it. So as I said, like it should be very easy to set up ClusterFuzz Lite. It's built for this purpose. We have many users, and that's sort of evidence for that. The first thing you need to do to use ClusterFuzz Lite is write libfuzzer harnesses. This is basically just consists of implementing like an API that libfuzzer will call into. And this API just needs to accept like a byte buffer, and you pass that byte buffer to the code you want to fuzz. This is fairly easy to do. Like you see this example from OpenSSL, or I think Boring SSL, is only about 20 lines. And there's a lot more details on writing libfuzzer harnesses at the libfuzzer documentation. And then the next step is just sort of like configuration so that ClusterFuzz Lite can build your fuzzers. This just consists of a bunch of other small files. So first you've got a YAML file that just declares the language your project is written in. You got like a Docker file just to install any dependencies you need to build the project. And then finally you have a bash script that is really just a wrapper around your own build system to build fuzzers for your project. And that's really all you need to like support any of the core functionality of ClusterFuzz Lite. But to actually run it, you're going to need to figure out where you want to do that. And so I think I've like mentioned it a few times, but like it could be run, ClusterFuzz Lite could be run in different CI systems. So we support like Google Cloud Build, we support Prow. It's easy to add support for other systems. And of course, we support like GitHub Actions, which I think have probably like exploded somewhat in popularity just because, so much code is developed on GitHub, and this just makes it convenient. So to take advantage of ClusterFuzz Lite, once you've done those previous steps, you basically could just like copy and paste these 20-line or 30-line workflow files to use ClusterFuzz Lite. So it's really trivial to set up, I think, especially if you know like fuzzing already and like you're familiar with fuzzing. And actually this previous process is actually quite similar to OSS fuzz. So if you've used OSS fuzz on an open source project and you now are on a proprietary project and want to use want to do fuzzing, you should be pretty familiar with this process. So some like future ideas for extending this even further that I've had, just because we got a bit of time left. So I mentioned that ClusterFuzz Lite can use coverage information and diffs to target, to run fuzzers that actually affect the changed code. But one thing that would be interesting is if we know which code is changed, could we tell the fuzzer to focus on that particular area of the code? And there are some tools that have been released that do stuff like this, and maybe they would be useful in a CI context. Actually, one reason why I'm not using, I think, like the current generation of them is just because I think it's, I was a bit worried about like the speed. Like there's some extra steps, and if it slows down fuzzing, it's probably not worth it for me. But if the fuzzer were capable of knowing what it's fuzzing, maybe we could use better heuristics than just quitting after 10 minutes. Like maybe we could say, if we've tested this code like 1 billion times, just quit because we're pretty confident there's no bugs in there. And finally, like I think one thing that is sort of lacking. So right, like I said, fuzzing sort of started on people's like desktops, and I want to make it user friendly. Like I want to make it maybe end up back on the user's desktop, but be user friendly this time in a way that like developers would use and not just like hackers would use. So right, like you don't only run unit tests in your CI, you run it locally. Maybe like you should have a way to quickly run these fuzzers in like a cluster fuzz light style way locally. Ooh. So to conclude my talk, you should fuzz your code because if you don't, someone else will and find vulnerabilities in them in your code. And CI fuzzing can really help catch a lot of vulnerabilities before they're merged into your code, and really, it's like a very cheap way to get a lot of the benefits of continuous fuzzing. And finally, Cluster Fuzz Lite makes it very easy to fuzz as part of CI. So to end off, we could do a Q&A, but here's just like my contact info and a link to the Cluster Fuzz Lite repo. And if you have any questions, feel free to ask them now or reach out to me by by email or file an issue. I'm very eager to like help people. Thanks.
Nice, Jonathan. That was super insightful and interesting.
Thanks.
And I'll be honest with you, I had to step away for a moment, and I came back, and the first thing I heard was cluster fuzz, and I just bursted out laughing because I love to play on the name there.
Yeah, it's one of the better named tools we have. Yeah.
Yeah. As somebody, Zach Curtis in the chat said, please tell me the next name will be Fuzz Lightyear.
There's some other like people involved in fuzzing that wanted to name some tool that, but that's not. I think we're not going to go with that name.
Okay. Fair enough. Cool.
I was going to call it Diet Cluster Fuzz initially, though.
Cluster Fuzz Light is the European version, apparently.
Yeah, exactly. The light beer.
So Steve asked a couple questions. I paraphrased one because I think you might have answered it when you showed the demonstration. But the first being that, and forgive me, Steve, if I paraphrase this incorrectly, but does implementing fuzzing in our pipelines require deploying the applications? And do you have any experiences implementing it like that?
I'm not. Yeah, do you want to go on?
No, go right ahead.
Yeah, so I'm not entirely 100% sure what you mean by deploying. Like I think. Like, I guess if you had some like sort of CMS, like you would mean like deploying the entire CMS to like a web server. Typically, these fuzzers that I'm talking about are run on like almost like the unit test level.
Yeah.
So you wouldn't involve deploying your whole application. You would just like, be writing something that looks like a unit test to test like a parser or just like a smaller component than like a whole web app, I'd say.
Yeah, when you were showing it, it reminded me of fixture testing, where you write a harness around a piece of code or a section or a library, and you're latching into it like like a wiring harness would be, right?
Yeah, exactly. Yeah.
Very cool. Second question there was, is there support for containers, or does the application need to be running locally for Cluster Fuzz Lite?
So all of like Cluster Fuzz Lite really sort of happens in Docker. And that's actually like maybe like a restriction, like, if you can't build your project on like Ubuntu, like right now we're not like supporting other sorts of like, distros or OSs. It doesn't need, the application doesn't need to be running at all really, and not locally. Like, Cluster Fuzz Lite's really like like it was really built to run on GitHub Actions. And so, it definitely doesn't need anything local.
Very cool. So I had a question of my own, actually, while you were talking about it. So if fuzzing finds an actual defect in the code, and would it be the normal process then for me to go and add unit tests to wrap around that, so I'm not having to rely just on the fuzzers to find, you don't want to use a fuzzer for regression, I guess, right?
Yeah, actually, so look, we definitely recommended that in the past. Cluster Fuzz Lite actually will catch like just like automatically catch any regressions that it's previously found. So yeah, like you can like, and it can determine we can deterministically find them. So like you can, but yeah, it's pretty common. Like in Chrome, when someone would find like, if there were like a bug in V8 Chrome's JavaScript engine that were found through fuzzing, people would oftentimes write like a unit test just to ensure that, that bug wasn't reintroduced.
Right.
Just to deterministically ensure it rather than like relying on the randomness.
Very cool. Brian, you got anything you wanted to ask?
Yeah. My question was, I believe I saw at one point in your slides that the programming languages that are currently supported, is there potential, and it was like C, C++, Python, Rust, is there potential in the future to expand what programming languages and ecosystems are supported?
Yeah, so I think like probably any LLVM language will be pretty easy to support, just because like a lot of our tooling works well with that. I think we're looking to expand it to JavaScript, but I don't know. I'm not hip enough to know what other languages there are besides those that people would want to. I guess maybe like PHP is probably another pretty popular one that we're gonna miss, or Perl. But yeah, I don't really see us. At least like a lot of these tools end up getting developed by like colleagues of mine, and like since we don't really use like PHP very much, like it just probably someone else would have to implement it.
So you're telling me QBasic is out of the question then?
Yeah, probably.
Okay. Damn. All right. Well, thank you so much, Jonathan. This was super helpful. Appreciate you joining us and teaching me and everyone else here about fuzzing. And yeah, appreciate you.
Yeah, thanks. See you.
That was cool.
Very, very cool. So next up, folks, we're going to jump right into the next session. It is Threat Modeling Kubernetes, a Lightspeed introduction. And I just realized that we had some speaker bios in our overall rundown sheet. So sorry for the previous speakers, but I'm going to do a quick little short read through of the bio here for Lewis, who's going to be our next speaker. Lewis orchestrates containers by day and hacks them at night. He's consulted in many roles, from developing software on bare metal to building the infrastructure in the cloud. He's the head of training at Control Plane, and he's our next speaker for DevSecCon24. Let's bring Lewis on.
Hey guys.
How did I do, Lewis? Was that pretty good?
It's always terrifying to hear your bios. What did I write about myself those months ago? What kind of mood was I in? And no, you did a fabulous job. Thank you for such a lovely introduction.
No problem. So are you saying I have a career in voiceover work someday, please?
Hey, take my money. Yes, take my slide deck if you want, actually. Yeah, definitely. Yeah.
All right, cool. Well, I'm looking forward to hearing more about this, and me and Eric will leave you to it.
Cool. Well, again, thank you for such a lovely introduction. Hey, everyone. Hope you're having a great day wherever you're based. I'm based over in Europe. Disclose more information on that in a moment. But this talk is about threat modeling Kubernetes at light speed. That might be a lie, but we will figure it out now. If you want to get hold of me, best find me on Twitter. Feel free to hit me in the DMs as well. But yes, I work for this company called Control Plane. So we do DevSecOps. We just like security. We like tough problems to solve. So if you're doing anything in the cloud and you want to be more secure and you've got some problems, then please feel free to reach out to us. We just love solving difficult issues. Now, whilst I do have your attention, one of my favorite speakers likes to draw attention to other issues outside of what we're talking about today. So I'm just going to take a moment of your time just to talk about mental health. I suffer from depression, and I know I'm not the only one who does. This talk that you're about to hear today is all about standing up and having your voice heard. And so that's what I'd like just to pass on to you at this moment. Your problems are your problems, and they are valid. You are not alone. If you do suffer from depression, then please raise your voice. Make sure that other people know, because you're awesome and fantastic. Now, the other mitigation for this talk is that I am always learning, and I'm really happy with that. Maybe my role of head of training probably alludes to that at points. The terms that I use are what I know of, and I appreciate the time and effort that it takes to write, maintain, and contribute to open source. So any terminology that I use during this talk today might feel aggressive because we are dealing with bad things happening. If I do offend you in any way, please feel free to reach out to me so that I can continue to learn. But let's get into this now. What is threat modeling? So threat modeling is identifying and enumerating threats and vulnerabilities. We're devising mitigations and we're prioritizing residual risks, and we're escalating through the most important risks. You should try to build the first version of threat modeling without outside influence. Then you can pull in external sources to cross-check for groups thinking. Threat modeling can be performed at any stage of a project, but to quote the Smiths, how soon is now? The earlier you start, the better it will be. And this isn't a shift left to someone else from the security team. This is about being, for me, a decent human being and respecting other people's information and lives. But we'll discuss more about that during the talk. Now, diversity. For threat modeling, we need everyone involved. So race, gender, age, all shapes and sizes, everyone should be involved with threat modeling. Absolutely everyone. From development, operations, QA, product, business stakeholders, security. Even about where you work. If you're back into an office, then you might want to potentially speak to people who are at the front desk or people who are serving you food, because all these people are part of this process that keeps the product moving. Now, I also help out in CTFs at KubeCon for security days. I can't really remember saying this quote, and I don't really know where it came from. But my point is that I felt comfortable to share this whilst I was on stage. This alludes to imposter syndrome. I see the best in everyone else, but I don't really think too much about myself at times. I think that I'm not the only one who feels like that. As an industry, we focus on what we don't know rather than what we do know. Now, Ian is someone who I have the utmost respect for, and Ian gives me, in saying stuff like this, gives me the confidence to be here to stand in front of you today. So make sure that you're more like Ian, and make sure that you can empower others to make sure that they feel comfortable in sharing what their opinions are so that their voice can be heard. Now, how to threat model. We're going to go through these 4 steps throughout this talk today. What are we building? What can go wrong once it's built? What are we going to do about the things that can go wrong? And are we doing a good job? Now, at this stage, have a think about why not run this threat modeling workshop at your own place. Let's get you into a position where you can talk with confidence to be able to run this workshop. So back to our points. WTF are we building here? We have an assumption here on this talk that you've got a bit of an understanding as to Kubernetes. We're going to be more focused towards threat modeling aspect. If you do have questions, again, I'll share my Twitter handle at the end. Please feel free to drop me a message. It's my day job, but equally, I love helping others. So your business, the way you work, is not my business, unless I do work with you, but let's leave it. My point here is that all businesses are, again, different shapes and sizes. You might be working for a large multinational corporation that's existed since, some would say, the dawn of time. And some other people in this conference today, they might have created their startup this morning. And now you're just trying to figure out the product that you need to launch. Now, that's not all businesses are the shape and size. And this is also the same for your adversary. So we're going to have a look at different types of adversaries that we might have later in the talk. But what type of damage can be inflicted? So we could have reputational damage or financial loss. Threats represent potential ways for information assets can be attacked. Let's use an example of an information asset. So is anyone watching this talk right now, are you willing to send me your credit card number and potentially CVV number in the chat? Hopefully you don't. But, and I hope that's because you don't feel comfortable to do so. You don't want to share that information. Equally, I got some Post-it notes here. So this is my database. So if you do send me your credit card, then I will store it here. And again, I really hope at this stage no one is sending me their credit card details. If you are, we'll figure that problem afterwards. Now, in either case, threats can exist which, if realized, could compromise one or more of the following key priorities of the data. So we got confidentiality. So if I got access to your credit card and your CVV digits of a credit card number, then I've got access to some information. Integrity. So if I want to pay, say, let's talk about James. Say I want to pay James £5. But if Andy modifies the request that I send, then Andy might receive that £10. That's an issue with our integrity. Finally, we have availability. So am I available to complete this transaction? Can I actually send this request across? Now, back to our case studies. There should be a scheme in place for how important the information is. So how much money is your business willing to lose? So let's put a figure on that money. Let's say 400,000, and we'll use dollars as we're now in the American time zone. If you're a startup, if you've just started up your business today and you're counting the pennies, then $4,000 is a lot. $400,000 incidentally is a lot of money, and that's a risk that you might not be able to afford. Whereas if you're a multinational company, then that could be cheaper, essentially, than fixing a problem. But let's look at it from a different perspective now. So instead of talking about money, let's talk about data. So how much customer data could you lose? So let's say the customer data in this instance is the name, the postal address, and a personal contact number. Now, if you have a startup again, then you might say to yourself, well, actually, our customer base is potentially just our family and some close friends. It's a risk, I guess, we're willing to take. Whereas if you're a multinational bank, for instance, and it's associated with people's life savings, all of a sudden, that name, address, and personal mobile number, if that information gets out into the public, then that is a huge cost, from reputation, from fines, everything else. So I guess that's almost like a joke to an extent, because I don't think that would happen. But there's also a serious aspect to this, and that is loss of life. So what happens when a secret needs to be a secret? So you might have personal life choices, and they might not be aligned with, say, the politics where you live or other religious people around you. What happens if someone finds out that personal information that you thought was secret? What happens if they find out? And also military. What happens if someone's identified as being somewhere because they're running around a track and they're keeping look on their track times and sharing with others? And this isn't just down to the person in this instance either. This is also about the people around them as well. It's quite quick and easy to find information on people. So if they can be identified and other people around them, then this could all go wrong. So I hope I have your attention when I say that this information is really important to us. Now let's have a look at our adversary matrix here. So we're going to start in the top left, and we're going to look at a vandal. Now a vandal is someone that I would say does a little bit of this for fun. They look at YouTube videos. I guess they don't think they're breaking the world. It might be like back at school, you might have been looking at running Quake or Counter-Strike on your school network. That to me is a script kiddie. Now, going on from a script kiddie, you might have a motivated individual. So who is a motivated individual? Well, if you're doing a startup, they might be a competing startup. This might be someone who's taken just doesn't like you. This could be someone that you came and said hi to you, but you didn't recognize them, and they've taken it personally. They might be motivated in a way that they want to just either take down your website for a moment or just make you look bad. Now, with such terrible things to say, I would like to introduce you to Freddie. Now, Freddie is an amazing, amazing person. They recently came up to where I'm based. I'm a chapter leader, and they gave a walkthrough about Hack the Box and how they do it. If you're interested in learning more about these techniques, about how you can breach from that perspective, then this is someone I would definitely recommend that you follow. Now, moving on from motivated individual, let's look at insiders. So a motivated individual, potentially, I'm thinking that they're outside of our organization. Now, what happens if they're inside your organization? Well, bad things, potentially. I probably prefer them to be outside, but anyway, it doesn't matter. It's not great, but that's where we go. We can't control other people and how they feel. So this might be someone who's disgruntled. Maybe they've seen some information to say that they're actually earning 20% less than everyone else on the same job or something. So all of a sudden, they've got a reason to feel a bit hard done by the business. They could also be manipulated. And again, we'll look into deeper why people might get manipulated, but equally think about over the last couple of years, think why we got these virtual conferences with COVID. During COVID, lots of people used the internet as a way to be able to connect to networks and share personal information again, and in places where they deemed to have trust. This information could also manipulate people. And that's what leads me on to the next part about being organized crime. So how can people be manipulated? Well, it could be physical violence. It could literally be that something bad's going to happen if you don't do this for me. And that is very much a Hollywood kind of thought. But the one that I think is a lot harder to deal with is to say, well, what happens if, say that there's a GoFundMe page that you put in place for a sick relative and you're trying to raise some money for medical bills. What happens if an organized crime person comes to you and says, right, you need to have this amount. I'll give you that if you give me access to this. And we're very privileged to be able to work in an industry where our salaries are quite good. But then what happens if it's at this moment in time where you feel comfortable, but then all of a sudden you have to make this decision? Now, and the other point of stress here is, up until this point, I've lived through either 2 or 3 recessions. I don't know what's happening right now in the world. I've lived through a pandemic. I've lived through a volcano that caused air travel to cease. And I've also lived through Leicester City winning the Premier League. None of these things I would expect to, like, maybe possibly one of these things I would expect to happen, but not all of them. So even though right now you might feel comfortable, what happens in the future? So I'd like to play a quick game here. So I'm going to call this one The Apprentice. So close your eyes and think that you're at either a conference, a gig, or a sports event in person. Now, there could be 10 people, 100 people, 1,000, or 100,000 people. And just look around you. And now think of this as your organization, as where you work. So of all these people that work in the organization, I'm just going to give a shout out to Steve. Steve, if you could raise your hand in this flood of people. I sent you an email today, Steve, because I identified you as a C-level exec thanks to some website where we all share our careers. I emailed you your password because I found your password. And not only did I find your password, but I used it to access your machine. And I've taken a webcam video of you, which I don't think it's going to win any Oscars, but I don't think you want anyone else to see your performance. So this doesn't sound too good for Steve right now. And I'm just trying to manipulate Steve on all the emotional levels, just so that I can get Steve to do what I want to do. Now, this might cause you to be like, well, that's funny, because we know that it's probably just from a security breach. Exactly. Like, so this data might have been released from elsewhere, from another thing. And they just use the same password with that email address. But it allows us leverage. So it's important right here to educate your team on security. So show them, have I been pwned? Explain to them about what happens when these things occur. Look towards password managers so that they don't use the same password for absolutely everything on the internet. But again, give them the confidence that they can come to you, that they don't need to have to be ashamed to come to you to say they think something's gone wrong. Now back to our adversary matrix, let's have a look at the Cloud Service Insider. So this isn't in your office anymore, this isn't within your organization, but thanks to the cloud, we're renting someone else's computer. But this computer does exist somewhere in the world. At a recent conference, I was able to touch the cloud because they brought a cloud server with them. How can you trust that person who's touching that cloud server? How can you trust a person who's employed by a third party that you're dependent on to write the code and that's all been signed and processed? How do we know that that's been checked? How do we know these things? So that's also someone else that we could have an issue with. Now, going on to our final game of who's sat next to you anyway, go back to wherever you were in your mind palace with all those people. And now, if you're looking in that direction, look the other way, and I think you'll be able to see Sophia is sat next to you right now, smiling back. You do know that Sophia works for a government agency with unlimited funds towards offensive security, don't you? And you also know that Sophia isn't their real name, because that's an identity that was produced by a government for them. How do you manage that threat? How do you manage it when you've got a government agency who has unlimited budget, lots of time and resource to spend on new offensive techniques, and have access to undisclosed information prior to public knowledge? So we're going to try and do our best in this. So here is an example of a section of the data flow diagram that we use in our full workshop for threat modeling Kubernetes. A data flow diagram should describe the complete set of data, the trust boundaries, all user roles, all network interfaces. We should make it self-contained, and most importantly here, it should be accurate. To make this easier for others to consume and contribute towards, there can be many levels that drill down further into system components. So in this instance, remember to drop the ladder for others so that they have the ability to climb. Now, here's another example of a Cncf Financial Services User Group Kubernetes data flow diagram. The link is within the slides. We've identified state flow with the black arrows, and the black arrows are crossing a machine segregation between nodes, as can be seen with the green boundaries. There is a lot of information here, but if you want to learn more about these, then please follow the link to the repo. So how can an attacker look for an entry point? Well, publicly available information is the easiest route in. Now, Rory is someone, again, that I and many of us look up to in the industry. He has a fantastic blog post about finding publicly accessible clusters. You might think to yourself, why would someone want to have a publicly accessible cluster? Well, as you might have seen, Kubernetes is kind of a big thing at the moment, and there's still people coming into this and still getting started in learning. When I learn, I usually make mistakes unknowingly, but that is how I learn. And so on that basis, this is why we need a threat model again. This is why we need to try to figure out, when we're putting things in place, what is the threat associated with it. So now we'll go on to what can, so now that we know what we're building, let's have a look at what can go wrong. So for example, the alignment of this header has gone wrong. Now, this is where your experience is required. Has anyone heard of a term, have you ever used the term secret source when building products? What happens when someone else finds out about your secret source? Well, it's no longer secret anymore. If something doesn't look or feel right, now is the time to raise it. We can also use threat intelligence sources, such as these listed here. And this is lots of people collating information to help us out. And as associated with what I feel with cloud native, all these intelligence sources are us standing on the shoulders of giants. So these techniques are our starting points. And from there, we use modeling techniques such as stride and attack trees to dive into our use case detail. So let's just have a quick look at the Microsoft threat matrix for Kubernetes. Again, we'll be touching on a few of these, but the main thing that I would like you just to be aware of here is that we got red and green. Red is a depreciated technique and green are new techniques. Kubernetes is constantly evolving and we need to evolve with it too. So we're going to talk through the stride modeling technique now. I can never really remember what stride stands for off the top of my head. I should practice it more. But what would we stride? We stride the process, the data flows, stores, and actors. We want to know what can go wrong. So S stands for spoofing. How do you actually know that I'm Lewis? How do you know that I don't have a green screen around me and that I'm not using like a snap filter on my face? Also, what are my intentions in giving this talk to you? What am I actually thinking about teaching you about threat modeling, or am I just trying to push you into a direction to do something else? But let's go to banking for an example. Say that you got access to someone's email address and you saw all the invoices that they sent out. You wrote a little script and that as a reply to say, sorry, we just changed our bank account details to this. Please, can you pay the invoice on this bank account? If someone receives that email, they don't know the difference. Tampering. Who has access to what? Can someone flip a bit? If I've got access to a banking system, can I increase someone's credit? And equally, we used this in an example a moment ago with James and Andy, where Andy was able to change the amount of money that he was sending. Repudiation. This is my word against your word. Who are you going to trust? Is our system logging suggesting that it's business as usual? The modified request that we did in our banking example was done in transit. And so if it's in transit, how do we know that this request has been received and it hasn't been manipulated? From our point of view, everything was fine. And if we go back to the James and Andy example, well, I'll ask Andy. But again, how can I trust Andy? If Andy says, well, no, I didn't receive any funds, how do I know that? I is for information disclosure. So does anyone want to put their credit card CV number in the chat? No, because you don't want to disclose that information. Also, just if someone's left their mobile phone unlocked on the table next to you, you could go through and have a look through so much of their information potentially. Or this could be, say, like an S3 bucket that's publicly available. Denial of service attack, too much information to process, too many questions all at once. If we do a denial of service onto an API endpoint, can the administrator get information back from a Kubernetes cluster as to actually what's running and what's happening? So finally, we got elevation of privilege. How do we get to the backstage area? Do I just put on a different lanyard to be able to pretend to be something else? But then equally, what if it's a service account that I use? Does it give me access to higher set privileges? So we build from Stride and we visualize with attack trees. Attack trees helps to identify risks to our resources and the likelihood of them happening. We don't want to have too much information though, so focus on quality, not quantity at this stage, and be confident in delivering concise documentation. So we've put this example together of carrying a briefcase to a locker. The light green are OR nodes, so these are our options available to us. The blue would be AND nodes. So OR means that any of the child elements, and AND means that both childs would have, or all children would have to complete to be able to access. Now, Kelly Shortridge has shown us how to use GraphViz to build attack trees. Deciduous is another option available to code an attack tree. We have also created an example available within this Git repo. So let's have a look at what can go wrong in Kubernetes. So I'm going to speed through this one now, but try and name this Kubernetes attack. So looking at our wheel of misfortune, what can go wrong? So is there an R? Do I have an A? And do I have a C? So at this point, I'm going to guess RBAC misconfigurity. Now, you might have seen a problem here. I didn't think about how long misconfiguration was when I started this, but I fixed it now just by a misconfiguration on the end. Now, that's one thing that can go wrong in Kubernetes, but there's lots that we can do. So let's have a look at our workloads. So our pods, we could have we could have a container breakout, file systems, host mounts, hostile containers, the container runtime itself, the configuration of our pod, the pod security context and the service accounts associated with it. With networking, we might have intrapod issues. We could have interpod issues again. We have no workload identity by default, and we have no network policy by default. Storage, we could have attacking volumes. We have the dangers of host mounts. We could also have no encryption at rest. So if we're using an etcd, well, etcd being used by the control plane to store Kubernetes state, also persistent storage to run the state of our workloads. IAM. So do we have a pivot to attack the cloud API or pivot to attack the Kubernetes API? Or can we use IAM to exploit app workflows? So in summary, lots can go wrong, but don't be scared. Just take each day as it comes and push forward. Make a start on it now and it will get better. So this is only a small subsection of an attack tree for Kubernetes. We can review these attacks to see how well they can be scoped. Do our attackers have access to resources that can enable these? This is available instantly on the same repo. So now we know what can go wrong. What are we going to do about it? Well, we could do absolutely nothing. And I joke, but if we didn't complete the last step, then you are doing absolutely nothing. But in becoming aware of the risks, you can determine your own threat model. And we have all performed a personal threat model. During COVID, you had to make decisions as to, all those decisions about staying in your house, being away from others. Are you willing to travel? Are you going to do these things? You've already threat modeled. So when I'm talking about threat modeling now, don't be scared of it. You're already doing it. So we have our shared responsibility model. So this is a choice of where you run your cluster and the effects of your threat model. So if you're running it as a hosted service, then your provider is managing a number of the controls. If you're running your own data center, then you're having to manage your control plane. So with risk management, follow what Marie Kondo does and just Marie Kondo it away. If we can avoid it, get it out. If we can mitigate it, then we can make this better and this brings us joy. So we need to work harder for it. We can also accept it, which is just, well, this doesn't affect us. Finally, we can transfer this. So we could pass this to legal to deal with, and I'm sure that that will bring them joy. So we have our types of controls. We have preventative, so shifting knowledge left, empowering others to have this mindset. We could also look at tools like KubeSec and OPA to provide constructive feedback to people making changes. Detective, so we can export and monitor logs, tools like Cilium or Falco or anything else. Corrective, something is being triggered by a log event. For example, if you've got a big red button on your desk that when you hit it, it just kills everything, that can be your corrective measure, just like pulling the power cable out of the box. And just be careful with your controls as well. If you've got old school controls which aren't following best practices nowadays, such as high availability, highly available means being highly available. So look towards GitOps, Flux, CI/CD, less manual and more automation. Kubernetes and Cloud IAM is at the center of cloud native security. So review your permissions regularly. User management processes are key. Review onboarding and offboarding processes for joiners, movers, and leavers, or JML. Implement strong access control policies. Default Kubernetes service account should not be used. Create a dedicated service account for every workload, its own workload identity. Workloads will interact with Kubernetes API or the cloud via a workload identity integration. Cloud provider services can help, so IAM roles for service accounts in AWS or workload identity in GKE. The RSA uses service account token volume protections, and this is just one benefit of using a managed offering. For cryptography, strong workload identities, Spire can be used. Spire is a production-ready implementation of a Spiffy's API. Focus towards least privileged pods. Make sure that we can't run things that we don't want to. Review what the workloads are being submitted to the API. Use IDS to report on suspicious behavior and automated securing testing in your pipelines. Now, has anyone talked about the supply chain at this conference so far? But this slide is just my kind of hot take on it, but also look towards Sigstore too. Luke Hines is a fantastic individual behind part of it. And he is one of the people that I'm just so, I've had the pleasure to get to know over the last year. Enforce network policy. Who needs access to the Kubernetes API? Don't put it on the public internet if possible. Check the capabilities of your pods. What do your pods actually need? Anything that's public facing needs to be locked down as well. And if it doesn't need to be near the public, and put it as far away from public as possible. And communication with your cluster is key too. Manage your secrets with whatever makes you happy. Whatever it is, just make sure that you're managing them. A mission control to use context of what's being shared. No one should be able to read what's in my volume, and no one can read what's in my volume. That is how I like to have my volumes. So we have controls for the security requirements. I'm giving a talk at the moment, and I understand that you're living in your real life. We have struggles from business as well and everything else around us that we might not be able to share or show. So just do the best job that you can, prioritize risk, and do what you can. It's important to look back as well as forward. So have we achieved what we have set out to do? Look to others for their reviews. Is there something that you have missed out? Testing, 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 which we'll look at now in the next slide. And as time moves on, our acceptable level may change. Document decisions made now so that you are consistent going forward. Select security controls for implementation. Map these controls onto the attack trees. This provides a direct means of evaluating effectiveness. Visual representations are easier to reason about. Identify how many nodes and branches of the attack tree are covered by the mitigating controls. This assesses the resulting security of the system. If enough security controls are defined, any new attacks added to the tree should be mitigated by existing controls. So in this Git repo, you'll find an example of using GOS to test out a security requirement of our cluster. The TLDR is that if a test fails, the security requirement is not being met, and this requires a review. It allows your team to continue to contribute code with confidence. Now we're coming to the end, and I haven't spoken about Wales so far. I'm proud about where I come from, and I feel that you should be proud about where you come from too. I am a chapter leader for DevSecCon Wales, and we are castles. We have so many castles in Wales. And I feel that castles are the OG to threat modeling. If you ever get the opportunity to walk around a castle, this is it. Just like look at this and just think about how they threat modeled and how all of this architecture is built to keep people out. But to that as well, I thought there's a song from Wales that's a good way to leave this talk. It only takes one project to identify 1,000 threats, and it only takes one threat to burn 1,000 projects. So on that, I would like to say thank you for your time. I hope you enjoyed the rest of your day, and I hope you enjoyed the rest of the conference. Thank you.
That was fantastic. Lewis, if that is who you really are, by the way, because now you got me. I mean, I'm already a paranoid individual, but after this session, I'm a bit more paranoid. Thank you very much.
There's a group that can help you with this from after my talk. So it's been set up, and so yeah, it's there's a lot that goes on in here. So at least you're outside of it, I guess.
Yes. Well, one, I want to thank you for your message on mental health at the beginning. It means a lot. I appreciate it. And two, yeah, like this was fantastic in terms of just making me aware, because I'm not very knowledgeable in Kubernetes, but hearing of all the different ways of thinking about possible threats that are available or could be happening in that space, let alone gets me thinking beyond that too for other development practices that I have in place for my own projects or on a team and so forth. So thank you so much for that. Yeah. So one question we got from the chat, and that was from Sharat, I believe, that they had for you, was from a risk management lens. Oops, that went away. From a risk management lens, how are threats different for risks?
From a risk management lens, how are threats different for? Great question. And this is taking me off. This is difficulty with threat modeling. It's the context that we're putting it in, because we're trying to put process into something that's been created. And I don't know if you guys would feel differently about this, so please feel free to join in the answer. The threats that you have, like, it might not incidentally be a threat. It could be that someone can jump onto this box, but then it's a case of, well, actually, we're fine with people jumping onto the box. If we're trying to use canary tokens and we want to show off our product, we want people to actively jump onto this box. But then equally, if you are a multinational organization that doesn't want anyone jumping anywhere near their boxes, then that's a huge threat. And that threat is identified as a risk to the business. So I hope that helps. But and again, I feel like I'm doing a bit of a British politician thing here of not necessarily answering a question, but answering my own question. So I hope that helps.
I think so. And then I see in chat, just referencing the closing of your talk, Zach Curtis was saying castles are the OG of threat modeling. Brilliant. They like that line. Well done.
Well, thank you for that as well. I'm happy with that. When I said that by accident one day, and it was like, oh, actually they are. So cool.
There you go. Perfect. Eric, did you have any other questions that you saw that popped up, or maybe some of your own to share?
No, just to follow on your answer to the question about threats and risks. I think it is a harder one to answer because they are kind of tied hand in hand. The way I always look at it is that the threat is kind of the hypothetical or even literal path to which you exploit a vulnerability or a risk, right? So it's kind of like the avenue by which the risk is exploited. Does that jive with you?
Yeah, that jives with me. It's it's always I can't express it when we do threat modeling. It's always when no threat models are the same, and this is a point about having your voice heard, and this is what I try to express within this talk is that just be confident in. I remember the first time I threat modeled, and I was terrified that I was saying the wrong thing. But the first thing I said was really valuable because it was another perception of our system that no one else had seen. And in doing so, it's just having that confidence just to raise your voice and say, right, I think this is a potential issue here. And it comes back to that issue of risk. Like the risk is this for your business, or is this for a consumer, or is this just for a random person somewhere who doesn't? Because we have lots of trust. The internet is based on trust. And when you share your information, who's managing that? And if it's you, then I hope you're doing a really good job. So, yeah.
Excellent. Well, Lewis, thank you so much. Again, really appreciate the message throughout the presentation today. It was fantastic. Learned a lot. And I want to let you know that it brought me joy, just to stick with that Marie Kondo reference. So thank you again, and appreciate having you here.
Well, thank you both as well for your sterling efforts today. So hopefully next time I get to see you soon in real life.
Sounds good. Yep.
Cool. Cheers, guys.
All right, Eric, I think we're up to break time, right? So that's where we get to take a nap, right?
Ah, yes. Good night.
People are going to just watch us sleep a little bit.
Yeah, that would be just must-see TV right there.
I don't know about you. Yeah, just turn on some lo-fi, let people relax. But I think this is a good point for people to take a break if you need to. Actually, I'm going to throw Eric for a loop here. All right, I'm going to throw everybody for a loop here. We're going to do a little stretch. How about that? Everybody's, I've been sitting for a while, barely gotten up in between sessions. Other people watching probably too. So you could do this standing up or sitting down. I'll do it sitting down so you can see me on camera, but we're going to do a quick stretch. Shout out to Allison Krug, a former colleague of mine that taught a bunch of us this. So you're gonna put your arms out straight across. They gotta be parallel to the floor. Okay. And then you're gonna do thumbs up. Things are going good, but they're gonna go bad in a moment. Okay. And then you're gonna pull your arms back behind your back just a little bit. You'll feel a little tension in your chest. Okay. Thumbs up still. And now slowly rotate your thumbs down. Oh yeah.
Oh, this is the thumbnail somebody's gonna post right here.
Yeah. Right there. Boom. Thumbs down. But make sure you're doing it like, clasping your fingers in there. I see you cheating. Yeah,
do it right.
I think you have to clasp your fingers in like you're doing a thumbs up and then rotate down. You feel that? Feel it?
I hear pops and cracks and
that's it. Eric's out of commission for the rest of the stream.
My 50-year-old body doesn't want to do that.
All right, shake that out. And then the other one's for carpal tunnel. You just put your hands back to back and push towards them and bend at the wrist a little bit and just hold that for a few seconds. Little stretch of that tendon or whatever it's called, and shake that out. All right, cool. All right. You feel better? I feel better.
I do.
That's good. How about you all in the chat? Let's see. Anybody in the chat? Eric is now a meme, says Zach Curtis, by the way.
That's right. It's part of the joy of being on live streams, right?
Yes, it is. It is. All right. I think we have some housekeeping things to talk about during the break too, don't we?
Do we? Do we now?
We do.
In front of me. So I was stretching.
Well, how about we give... Go ahead.
I was going to say, why don't we put up our graphic here and thank our sponsors. Oops. There we go. Thank you to all the great sponsors for DevSecCon24 2022. And yes, everybody give the applause. And I think it's good to mention also that all proceeds from the sponsors during DevSecCon24 will benefit global charities. Every penny is going to go to global charities driving inclusiveness within technology. So we're aiming to support local orgs across, globally across EMEA, APJ, and the Americas that are leading the movement to address inequality in the tech sector and drive inclusiveness and diversity within our local communities. So I just wanted to point that out. And thank again all of the great sponsors we have, and be sure to visit their booths. I think every one of them has some sort of freebie or giveaway they're doing.
I believe so, yeah. Doing some giveaways. Sponsor giveaways are happening in the booths. Check them out. Again, that's over on Hopin. If you're watching on YouTube, just a heads up on that. If you want to get over into Hopin, you go to the DevSecCon.com website, and it'll have a link to join via that mechanism, and you'll have access to the event booth. If you are on Hopin, there is an expo link on the left-hand side that you can go to check out and see the booths that are available there and some of the giveaways that they got going on. Thanks to our lovely, lovely sponsors. What else do we got? So much. Well, I think we should remind folks about DevSecCon global chapters, especially since Lewis was kind of talking about the Wales chapter. We have a bunch of different chapters, don't we? Where are they at, Eric?
There they are.
There it is. Yes.
Across 12 countries, 13 chapters. Our North American chapter is in Virginia Beach. And actually, we'd love to actually grow our North America presence. And let me get a screen share going here, and I'll show you how you could participate in that. Share. Come on, where's my screen? Share the right screen. There we go. So if you go to DevSecCon.com and go to community, get involved, and scroll down past the fold here, you can apply today to start a chapter if you're interested. And while you're here, poke around. Even if you don't want to start a chapter, poke around here, look around, see what you can volunteer and do, find events, or jump in Discord and start chatting live with us anytime you want.
Excellent. Yes. All right, I think that concludes the short break that we had there, and we're going to jump into our next session, which is a lightning talk. And our next speaker is Laurent Simon, is a security engineer in the Google open source security team. He works on tooling for software development lifecycle and supply chain integrity, and will be talking to us about assessing and improving the security practices of open source projects. So without further ado, let's bring Laurent on. Hey there, how you doing?
Hi, I'm doing well. How about you guys?
Doing well, doing well. Thank
Very
you.
well.
I'm excited to hear about what you have to share with us. So Eric and I are going to jump off and let you take it away.
Okay, cool. Thanks. All right. Hi, everyone. So yeah, thanks for the intro. I'm Laurent. I'm a security engineer at Google. And today I'll be talking about a project called Scorecard, which can help you assess and improve the security of open source projects. So I work at Google as a security engineer. I spend a lot of my time working with the OpenSSF on two of their main projects, the Scorecard project, which is the topic of this talk, and the Salsa project, which is a framework that helps secure your release pipeline. So I'm not sure everyone knows about the OpenSSF, so let me say a few words about it. The OpenSSF is the Open Source Security Foundation. It's an organization where multiple companies collaborate to help improve the security of open source software. We do this by writing tools such as Scorecard. We provide consulting, perform code audits, and sometimes also publish best practice documents. Everything in the OpenSSF is open. So we have public working groups, Slack channels, bi-weekly meetings that are open for everyone to join. If you're interested, take a look at the openssf.org and join the conversation. All right, so as most of you may know, most of the third-party dependencies in modern software come from open source, around 90% of them, and several critical pieces of software we use every day in production, such as Kubernetes or OpenSSL, come from open source. However, supply chain attacks are on the rise, and attackers are realizing that it's much easier to attack the supply chain than it is to find bugs in the actual software. And over the past 2 years, we've seen significant rise in these attacks, as illustrated in this slide here. In this slide, we have tried to visualize the various components of the supply chain. And as you can see, there are quite a lot of places where an attacker could try to target your project. Starting by just sending malicious pull requests to exploit an overprivileged CI run where you run your tests, for example. And I'll show a demo of this later in this talk. An attacker could also compromise your software source control system, which happened in the PHP attack a couple of years ago. An attacker could also compromise your build pipeline that happened to SolarWind, or an attacker could also try to compromise package manager account. This happened about just 2 weeks ago. Researchers showed that they could register expired domains and initiate reset password to take over package manager accounts. And last but not least, we see often attacks named typo squatting, where attackers registers common names or lookalike names in the hope of tricking users to install those dependencies instead of the genuine dependencies. Because of this, large attack surface, this is why the OpenSSF Scorecard project was created. In a nutshell, Scorecard is a tool that assesses a number of important security risks with a software development cycle for projects that are natively developed on GitHub. Scorecard can check whether you are following good practices. For example, are you using continuous testing, fuzzing, static analysis? This is an important signal because it reduces the chance of bugs, and it catches them early in the development cycle. Scorecard will also check whether you are updating your dependencies, or go also beyond that. It will check whether you have safe configuration settings on GitHub. One important setting is the so-called branch protection setting, which prevents code changes by malicious developers. We have other checks, such as the webhook check, which will verify whether you have enabled authentication in your webhook configuration. Scorecard doesn't just look at good practices, it also warns about anti-patterns. For example, if you have a secret which is accessible to an untrusted pull request, Scorecard will warn you about that. Scorecard will also warn you about whether your CI runs on GitHub, which are called GitHub workflows. It will warn you if they are overprivileged. And this is really important because an attacker could abuse those permissions, bypass code reviews, and change your code. Again, I'll show a demo of this later in the talk. There are two main use cases where we think Scorecard is beneficial. The first is to improve the security of your own project. And it can help you reduce the risk that your code will be tampered with by an attacker. Second, you can use Scorecard to assess the risk of your dependencies. For example, Scorecard can warn you if your dependencies appear to not be maintained. And that is a signal which tells you that the dependencies are likely not to receive security updates. So let's see some examples. And let's start with how you can use Scorecard to assess your dependencies. So this is pretty simple. All you have to do is run the CLI. In this example, we are running a Scorecard against a repo called sum/repo-dependency. Scorecard will output some warnings about security risks. For example, the top warning indicates that the project exposes a secret to untrusted pull request. The second warning indicates that the project uses the default CI permission, which include the ability to push code directly to the repository, which is really dangerous. And this last warning indicates that the project does not declare its dependencies in an immutable way. So if the dependency is later compromised and becomes malicious, your project would automatically download this malicious dependency, and it could compromise the project or a binary that you've compiled. This happened recently with the npm caller package attack. If you are using Go in your project, the official pkg.go.dev website now integrates better with Scorecard. At the bottom right of the image, you see a link. And if you click on it, it takes you to a website called deps.dev, which shows you all the Scorecard results for a package. It gives you results for each of the check and also an aggregate score. In this case, it's 5.2 out of 10. All right, so now let's move on how you can use Scorecard in your project and install Scorecard as a GitHub action. So for this, I need to share a different tab, so bear with me. 1 second. All right. All right, so this is a project I created, Scorecard minus example. So what you do if you want to install Scorecard, you go to that security tab here. All right, and then you go to the left, code scanning alerts. I have already installed Scorecard on this repository, so some alerts are already populated, but ignore this for a second. I'll show you, we'll go through some of them in a second. If you want to install Scorecard the first time, on the top right corner here, you have a button, Add Scanning Tool. Click on it. And here you can search for Scorecard. And click Configure. So this automatically populates the workflow file for Scorecard to run. And all you have to do is push that to your repository. Scorecard runs daily, every day, and also on every push to the main branch. And as soon as Scorecard runs, you will get alerts populated in the scanning dashboard that I showed earlier. Something that I want to mention is that Scorecard takes a path token as an optional input. You don't have to declare one, but if you don't, the branch protection check will be disabled. And this is due to a limitation of the current GitHub APIs. And we're working with GitHub to try to resolve this problem. So let's cancel the changes and look at some of the results. Scanning results. All right. So for example, if I click on the fuzzing check right here, you can see that scorecard is complaining that the project is not fuzzed, which is correct. And there's other kind of checks, as you can see. Let's look at a critical result that scorecard, a critical alert. So here in this alert, scorecard is complaining and claiming that there is a script injection vulnerability in this file presubmit.yaml due to this variable. All right, so let's take a look at the file. So roughly speaking, what's happening here is that this workflow is run on every pull request, and it roughly does the following. It does a bunch of printing, so it looks pretty innocuous. But it turns out that this is actually a vulnerable workflow. And to understand why, you have to know that when GitHub runs this script right here, it basically substitutes the variable right here with the title of the pull request provided by a potential attacker. And this allows someone who sends a pull request to gain remote code execution. So don't take my word for it. Let's just demo it right now that we can actually get remote code execution. So as you can see, the last commit on this repo is here from 2 hours ago. It's called update test.txt. So let's create a pull request real quick. Let's call it hello. Create a pull request. All right, and let's change the title. Oops, this, 1 second. All right, I'm back. Okay, so let's create the pull request with this weird looking title. All this is really doing is it's escaping the double quote and then pulling some content and executing it. All right. If we look at the actions that are being, you can see that the pre-submit has kicked off. It's being run. There's no interaction from the maintainer. The job has completed. If we look at we can see that it claimed DevSecCon crowd was here, which was the title, which is a word that was in the title of the pull request right here. And we can verify that there's a new commit that just happened, which is basically the remote code execution gave us access to push directly to the main branch of the repo. All right, so let's go back to the slides. All right, so that's the end of the demo. Let me real quickly say give you a few announcements. We have plenty of things coming up with the scorecard project. We have badges coming up soon, a website. We are also improving the scorecard action so that you can more easily view the results for your dependencies. And also, I'd like to give a shout out to this project, All-Star, which is an app from the OpenSSF, which helps you enforce policies at scale for scorecard results. So thanks, everyone. That's the end of my talk. Just a plug, like the OpenSSF community is open, and if you're interested in joining the conversation and get involved, click the link on the slide. Thank you.
Wow, that was really eye-opening, Laurent. I had not seen that attack vector before through GitHub PRs and the titles of it like that. That is super interesting, and thank you for bringing that to everyone's attention there. Eric, did we have any questions for?
I think we just got one from Catherine. It says, would I be able to enable scorecard in GitLab?
Yeah, so we're working on it. We don't have support for it yet. But yeah, it's in the pipeline. We have prioritized GitHub for now because they have more of the market share. But yeah, it's in the pipeline. And if anyone wants to help, like pull requests are welcome. In this case, probably a lot of pull requests.
Excellent. And again, shout out to OpenSSF for folks to check out and start contributing and be part of as well. Thank you so much, Laurent, and appreciate you being here.
Yeah, thanks for having me.
Right, see ya.
Bye, everyone.
All right, Eric, what do we have next now? I mean, we are just back to back rolling with these great sessions.
Going.
Yeah.
Okay, so next up we have Mackenzie, who is, I'm sorry, my notes are slow, but is a developer advocate with a passion for DevOps and code security, co-founder and former CTO of a health tech startup. And I'm not going to go any further. I'll let him introduce himself more than that. I'm really excited. We are going to be talking about, oh gosh, he's got a long title too, Exploiting Exposed Credentials in 2022, How Adversaries Discover and Exploit Leaked Secrets.
Ooh.
Nobody leaks their secrets. Nobody would ever
Nah.
commit to their GitHub repository a hash or share it on a live stream or anything like that.
I've never done anything like that. No way. All right, let's bring Mackenzie on. Hey, Mackenzie, welcome.
Hey guys, how you going?
Good.
Going well. How are you?
Good. Just chuckling in the background as you're talking there. But yeah, no, great to be here.
Great to have you. Well, without further ado, we'll get out of your way and let you take it away.
Well, excellent. So as was just being said, I have to work on shortening my titles a little bit, but I'm just trying to get as much as I can in there. But we'll be talking about exploiting secrets, exploiting credentials, what happens when you leak them, how secrets are leaked, how adversaries find them and use them basically to attack your organizations. So I like to start. I know most people probably kind of know what secrets are, what digital authentication credentials are, but I just want to start at the basics, get everyone kind of up on the same page, and then we can dive into some of the more technical meat of the presentation. So let's start with what are secrets? So secrets, I'm typically referring to things like API keys, your credential pairs, the credential pairs to your database, could be security certificates, could be a whole range of things. And the key that they all have in common is that these are authentication strings, right? We use these to authenticate ourselves with other systems, internal services, external services, SaaS tools. So these are really the crown jewels to your organization, and attackers really want and also likely need these to be able to get into your systems. They can use them to elevate their privileges. They can use them to what we call move laterally, so leapfrog into different services once they're inside. So these are really the crown jewels of your organization, and you really want to protect them. But we're at a bit of a problem with secrets, and that is that they're both highly sensitive that we need to protect, and we need to distribute them widely because a lot of people need secrets to be able to do their job. And this is because of a pretty big shift in how we build software today. Because way back when, we used to build these monolithic applications. These are things where the software needed everything to run was internal. So everything that software needed to run was inside it. But now we can leverage lots of different systems. So the simplest example is maybe a payment system, right? If you're building some software and application that needs to process credit cards for payment, are you going to build that all out yourself, find out what the financial regulations are, or are you just going to use Stripe or PayPal or some other service? So we extrapolate this to a lot of areas in our organizations. It could be open source components too that we're building on, but it can be SaaS platforms, it can be managed services, it can be cloud infrastructure. So this change has meant that we need to handle a lot of these secrets, right? And it means we need to distribute them and create a huge number of these in any given application. Now, the second problem is that code is actually a really leaky asset. I want to give through some examples of kind of how code has leaked into the public realm. But basically, we don't have adequate protection around code. And this is by design and is important because, code is something that we collaborate on and we need to be able to do that. But it means it's hard to protect. So when we get secrets inside our code, it creates a real problem. And then the last kind of piece to this fragile pyramid is that software developers are under a lot of pressure. We're trying to get our release cycle shorter. We have lots of competition. We're building very, very quickly. So this all together kind of combines this perfect storm for these secrets, these crown jewels of our organization to leak, to kind of be exploited by attackers. So just quickly, we can give a pretty good example of kind of how many of these secrets are. So let's say that we're building an application. And I used the example about Stripe before, but we can extrapolate this to lots of different services, right? If we're building the application in a Django framework or using Django, then we have Django keys that we need to manage. Maybe we're connecting into Twitter. Maybe we're using Okta as our authentication. Maybe we're using Algolia as our search function inside our application. So all of these different systems need to leverage secrets to be able to connect to them. And all of them can contain a lot of sensitive information or provide opportunities for adversaries to be able to jump between them. And then once we've built our application, right, we're not done with secrets yet because we need to host this application. We need to kind of make it accessible. So our infrastructure that we use deals with secrets too. Maybe we're hosting this on our AWS cloud. And so now we need to deal with AWS credentials. You know, we have to manage our code. So we're dealing with Git credentials. We have testing being done in our CI/CD pipelines when we're deploying apps. So we have credentials for those, and they can be really sensitive. I'll show an example of that. Right, so once we've built our application, we have some infrastructure in place, people can access it, right? Probably the marketing teams, the sales teams are going to want integration. So maybe we have Salesforce integrations, Grafana, Slack, all these other different areas. So now we have more secrets to deal with. And we haven't even started talking about the internal microsystems or microservices that you're creating that also probably leverage secrets for authentication, but aren't a named service like the other ones on here. So this is an oversimplified version, but we can see that very quickly we can end up with hundreds, thousands of these different services, and then we can end up with hundreds and thousands of different credentials, different secrets that we need to access them. So this is largely kind of the problem of how many secrets that we are dealing with as an organization today. Now, the last part of that component is the unwanted distribution of these secrets. Now, they can kind of leak in a lot of different ways, but the number one way that we lose track of these secrets is through code, particularly our version control systems. So you can imagine a situation where a secret gets hard-coded into source code, right? The developer is quickly trying to do something. Maybe they hard-code a credential to get something working. Maybe they're intending to remove it later before it goes on to the master, but it ends up in our source code. It ends up in our version control system. Now, immediately, this is then cloned onto multiple different developers' machines, right? So we've now lost track of where that secret's ended up. It's in our source code, plus it's on all the different developers' machines. Maybe it's been copied into some messaging systems like Slack. It's probably backed up into different servers everywhere. And it may even end up in our running application or end up in our deployment tools, maybe in Docker images. And the key thing about this is that we actually have no visibility. We have no idea where this secret has ended up. So we don't even know that this secret has actually been compromised. We don't know that this secret is in backups, is in different developers' machines. We don't know, we can't restrict who has access to it. So we end up with a problem that collectively we call secret sprawl, right? And attackers really rely on this concept of secret sprawl to be able to kind of exploit these secrets. And I have a quick demo that I want to show you here today. Now, they say you should never do live demos, but we're going to give it a go and we'll hope for the best. Usually you can rely on bad guys pretty well. So here I have a configuration file, a Python configuration file in a fake project. And right here we have an AWS credential. Now, this AWS credential isn't going to help you much if you want to do some Bitcoin mining, but what this is a canary token. Now, Lewis briefly spoke about canary tokens in an earlier session here, but essentially what this is going to do is every time someone tries to exploit this credential, they're going to let me know. It's going to notify me. And what I'm going to do is I'm going to do the number one sin that you can do when dealing with secrets. And I'm going to push this secret or this file into a public Git repository. So I'm just going to quickly do that.
No, Mackenzie, don't do that. Oh.
It's done. It's done. Now, what I have here is I have on my page, as I said, this is a canary token. What's going to happen is this is going to let me know every time someone tries and access that token. And I have about 20 minutes left on this presentation, and I'm going to see at the end how many people between now and in 20 minutes have tried to access my AWS credential, right? And I want to do this for a couple of reasons. One is I want to show that this problem is so widespread, but I also want to show that actually source code is being monitored, and there's a number of ways that attackers can do this. And I'll talk about that in a bit later. But now, let's have a look at some cases where attackers have been able to exploit these secrets in real life, not just hypothetical examples like the one we're doing. So in Uber, Uber actually had 2 instances where the credentials were exploited. Now, one was because an employee of Uber did exactly what I just did. They just pushed credentials in a public personal Git repository. Now, the key is that this was actually code for Uber, and I'm not sure what caused it. Perhaps they got confused with repositories. Perhaps they misconfigured their Git. But this ended up publicly on that employee's personal GitHub account. Attackers found it, and it gave access to an Amazon S3 bucket where they were able to gain access to sensitive information. They also had another example where in a private case where they had a private Git repository, so not public. And inside this, there was also Amazon S3 buckets that were hard-coded into the source code. So how did the attackers find these? Well, it was actually because of poor password hygiene. So some employees were using the same passwords for multiple systems. I think some of those other systems were compromised, and then they used that password to gain access to Git repositories where they found the sensitive information. So this illustrates kind of quite well both the public and the private aspect of not having secrets inside your source code. Now, another example, and probably one of my favorite ones, is that of CodeCov. So CodeCov was compromised early last year in a supply chain attack. So we just heard from Laurent about some supply chain attacks. So I want to talk about the CodeCov supply chain attack. So firstly, what is CodeCov? So CodeCov is a code coverage tool. Basically, what this tool does is it tests how much of your code is being tested by the other tools. It gives you a report of how much of your code is being tested by the other tools. So it does a very specific job. It sits in your CI/CD pipeline. Personally, I think it's a great tool. But this would be one of multiple tools that you would have. At the time of their breach, they had 20,000 users. So it was a significant user base. And some large companies, which I'll talk about, were using CodeCov. So what actually happened? So in CodeCov's kind of public main Docker image. So anyone could have downloaded this. This is a Docker image that people were using to run CodeCov. Inside this Docker image, there was a plain text file, a plain text credential, I should say. This credential gave access to their source code. So it gave access to the ability for them not only to be able to access the source code, for also be able to update their source code. So the attackers found this plain text credential in, again, their public Docker image. And once they had that, they were then able to inject some malicious code into CodeCov's code base. Now, they did it in a bash uploader file. It was a fairly ugly file. It was thousands of lines deep, and they injected just one line of code. And that line of code did something quite specific. It basically said, every time one of CodeCov's 20,000 customers is running it, take all the environment variables that are available and send them to me. Send them to the attacker. So when you're testing your application has to be able to build, it has to be able to run. So you have secrets in your environment variables, right? You have to access your database, your systems. Now, hopefully, you're using different credentials to test than you are in production. But it's not always the case. And it's certainly not the case that test credentials aren't always sensitive, because the adversaries were actually after a specific credential. They were after the Git credentials, the GitHub tokens for these customers, because this was something that was in the environment variables when CodeCov was running. So what were the attackers able to do? They were able to move from CodeCov's Docker image into their source code, turn their source code to their application malicious, and then move into the private code repositories of CodeCov's customers. So who were these customers? These customers were people like Twilio, Monday.com, HashiCorp, Rapid7, large companies with great security posture. The attackers were able to access the private source code of these companies. And these companies, the ones that I've just named, had to report that not only was their source code breached, but actually they had secrets in their source code. Now that included HashiCorp. HashiCorp is a fantastic company. They coined the phrase secret sprawl, and they build one of the best secret management products out there. And even they had secrets in their source code. So I'm willing to bet anything that if HashiCorp have secrets in their source code, you probably do too. And source code isn't impenetrable. This is one example how even if you do nothing wrong, adversaries can perhaps access your private source code. So this is a great example of kind of that supply chain attack going on. Now, the other thing to think about with private source code is that they don't always remain private. All right, we have hundreds of headlines about private source code being made public, or as I like to call it, involuntarily open sourced. So we have a lot of examples about these, and this is another area where your source code in and of itself can be a vulnerability. And I really like to kind of focus in on that point, because we know that our application can have a vulnerability, and we know that that application can have a vulnerability because of maybe something we did in our source code, but also our source code in and of itself can be a threat, can be vulnerable. So if we look at Twitch's source code, for example, that last year in October, their source code was involuntary open sourced via a torrent. We scanned Twitch's source code and we found over 6,000 secrets inside here. Now, that may sound like a lot, but at the scale of Twitch, it's actually pretty standard. In fact, Twitch beats the industry standard of what we typically would find in private source code for secrets. But that doesn't matter because we still found 194 AWS keys in Twitch's source code, 69 Twilio keys, a bunch of Google keys, and a whole bunch of other really sensitive information. We have a whole report on it if you're interested. But this just goes to show that private source code doesn't always remain private. And when it does leak out publicly, it can leak out a whole bunch more than just your source code. Now, in my opinion, the attackers in this exact example actually did Twitch a favor. They did Twitch a favor because they publicly announced that Twitch's source code has been breached. Had they not done this, then Twitch may not have known that all these secrets inside were compromised, because they were very quickly able to rotate a lot of these secrets so they were no longer a threat. But the attackers could have sold them. It happens regularly on the dark web, where you can sell credential accesses into companies. So it could have been a whole bunch worse. Now, another example is that of Samsung, NVIDIA, and Microsoft. Now, this year, a lot of source code from these companies, again, great companies, were involuntarily open sourced. And again, we were able to scan these and found huge amounts of secrets inside of them. I'm just going to talk about a specific type of secret in the case of NVIDIA. And that is that the NVIDIA had their signing keys inside their Git repositories. And these signing keys were actually used to sign malware intended for Windows. So they were able to basically authenticate software that was actually malware, and it was accepted by Windows machines because of NVIDIA's signing keys that were in their private repositories. Now, this breach is actually a result from the Lapsus group. Now, we later found out that Lapsus was a group of teenagers. So this leads you to the question, how did a group of teenagers breach the private source code of some incredible companies? Samsung, NVIDIA, Microsoft are fantastic companies with great security posture. So how did they do it? Well, here's a screenshot from the Lapsus Telegram channel, basically saying that they're after insiders. They're trying to recruit insiders. Specifically, the message says that we're recruiting employees, insiders at the following, and then they give a list of different companies. So I want you to think now about your source code and who has access to it. So when we're thinking about our secrets, I've said a lot, it's my favorite phrase, that they're the crown jewels of your organization, right? And as such, most companies will have great secrets management. They'll be tightly encrypted. The access to those secrets will be tightly controlled. So not everyone should or would have access to them. In fact, a select group of people would have access to a select certain group of credentials. But if these credentials end up inside your source code, now think about who has access to your source code. Your engineers obviously do, your developers, your product managers probably do, your team leaders do, and even your interns would. So if someone's trying to access your company, should they try and attack the secrets management software, which would be near impossible? Or do they try and find a disgruntled employee, an intern that's had a bad day, and give them a couple of grand so that you can access their private source code? Well, that is exactly how Lapsus was able to breach and find secrets inside some of the largest companies that we have. So I want to talk now about a report that will show kind of the scale of this. How big of a problem are leaked credentials? So each year, so I work for GitGuardian. We're a secrets detection company, and each year we release a report called the State of Secrets Report. Secret Sprawl. And this report looks at a number of different areas and how frequently we find secrets inside them. So we look at secrets in public places like public GitHub. We look at secrets inside public Docker images. So we talked about CodeCov and their Docker image. And we also look at secrets inside private code repositories. And then we publish these results and what we found and the types of secrets that we found. So if you want to know how many secrets are exposed on github.com, 6 million secrets were leaked last year in 2021. So GitGuardian scanned every single commit made to github.com. If you pushed source code to GitHub, we scanned it. So 6 million credentials we found. Now, this was from about 56 million users. Now, GitHub claim they have 75 million users. I'm sure they do. But 56 million users actually pushed code to GitHub last year. So this is a huge volume of code. It's billions of commits. And 6 million credentials is mind-blowing. But it's not just us that kind of realize this. Adversaries realize this too, and they actively monitor places like GitHub for secrets. So at the start of this talk, I leaked a credential on github.com. Now, I leaked that in my personal private repository. I'm not very active on GitHub lately, so there's no reason why an attacker would be monitoring me. But what actually happens is that GitHub has a public API, and this API updates regularly. So basically, what happens on GitHub is not just public, it's broadcast. So if you leak something, it's being broadcast to anyone, and anyone can, who monitors the GitHub API. So that is why I'm fairly confident at the end of this talk, I'll be able to show some people that have tried to exploit the credentials that I've lost. But I'm not alone. 6 million credentials were pushed to GitHub last year. So a mind-blowing number. So what type of secrets were leaked? Well, the main category is what we call other. So other is basically secrets that that could be access to lots of different things. They could be secrets being used for internal services. They could be secrets, could be kind of private keys or certificates that we don't really know exactly what they do, but we know that they're secrets. The second biggest category is data storage. So your database access. Your Amazon S3 buckets, for example. All of these are highly, highly sensitive. They can contain highly sensitive information. We shouldn't be hard coding them into our source code. We should be handling them correctly, putting them as environment variables. But 21% of the keys that we found, over 1 million keys that we found were actually giving access to databases and data storage. 15%, so just under 1 million, were actually to cloud providers. You don't need to be very imaginative to know what you can do with a cloud provider key. You can set up Bitcoin mining if you're not very imaginative. You can launch DDoS attacks. You can divert computing power. Or if you really don't like someone, you can just rack up a huge bill by stringing together large computers and running up kind of unimaginable numbers. So 15% nearly 1 million keys last year that we found were for cloud providers. Then we also have kind of development tools and messaging systems and version control platforms and some other categories too. My favorite is messaging systems because they're not very protected, but it's very easy to launch an internal phishing campaign if you have keys that will give you access to the internal messaging systems. We found over 500 GitHub tokens in commit messages. So if you don't understand this, if you're not very familiar with Git, this is basically putting your password to your email in the subject line, right? So you're adding a message to say what you've changed and you're putting in your GitHub token. So why is this significant? Well, it just shows that there's still lots of ambiguity and misunderstandings about how Git works. People are obviously thinking that this is how you authenticate themselves. So these people could have access to lots of different information, but they're prone for big configuration errors, or even doing silly things like adding secrets into commit messages. And just very quickly, if we look at kind of some of the cloud providers here, we can actually see that the one secret that's on the right trend and that's down is AWS keys. We're finding less AWS keys at the end of the year than at the start. So that's great. And this proves that we can actually make a difference, because AWS has done a great job in raising awareness around the fact that their keys are actually sensitive and shouldn't be made public. But at the same time, we also have new providers like PlanetScale and Supabase that have come onto the market. And already, even just a couple of months after PlanetScale was kind of officially launched, we started finding secrets to these providers on public GitHub. So it proves that we need to be really far ahead of the curve if you're going to try and prevent leaked secrets from kind of ending up in public spaces. Now, the other area that we find secrets that we talked about is inside public Docker images. So this is Docker Hub. So dockerhub.com is the largest place that you can store your Docker images, and there's over 8 million Docker images that are currently available on Docker Hub. And this was actually where you would download the code Docker image. So we scanned 10,000 Docker images to find out how many of them had secrets, and we found that nearly 5%, 4.6% if you want to be pedantic, contained at least one secret, one hard-coded plain text secret. So we found, out of the 10,000 that we found a total of 4,000 secrets. 1,200 of them were unique. So there was quite a few secrets being repeated inside those Docker images. But again, it can be very confusing of kind of how to build Docker images. We see a lot that people add in a secret, let's say to a package manager so they can access it in their Docker file. Then they remove it later because they know that it shouldn't be there. But actually, like Git, you can go back in history. Same with Docker. You can go back in history when you build something. It's built in layers. If you add something in the first layer and then put layers on top of it, that secret still exists. So we found a huge amount of secrets inside Docker images. And the last area that I want to talk about before we kind of go back to the experiment is how frequently are secrets in private repositories. So people have this false sense of security around private repositories that because it's behind some kind of authentication that it's secure. But we just proved that source code is very leaky. Lots of examples of involuntarily open sourced source code. So how much do we typically find inside private source code? So at GitGuardian, we took the average of our larger customers. So our larger customers, the average of them was a company with about 400 developers, so 400 engineers. So a fairly sizable company. Now, in a company this size, we found around about 1,000 unique secrets. So that's huge. So we look at Twitch. Well, Twitch is a whole lot larger than that. We found 6,000. It's pretty much on par. So it's a huge problem. And, unfortunately, attackers know this too. Now, each one of those 1,050 secrets were actually repeated on average 13 times throughout the Git history on different branches and in different areas. So why is that significant? Well, every time you find a secret, you have to investigate it. It doesn't matter if it's the same secret, because you're probably not aware of that. So if there's 13 of the same secret, it's going to have to be investigated 13 times. Now, in a company of 400 developers, there's typically 4 AppSec engineers. That means that each one of those AppSec engineers has to investigate, kind of communicate with the developer, rotate, republish their keys 3,400 times a year. That's huge amounts. If you did that all day, every day, and nothing else, and didn't work holidays and weekends, you still wouldn't be able to get through it. So this is how big of a problem that we have. And unlike us, attackers have time on their side. They can sift through that amount of information to find that gem, but we're under pressure. So this illustrates the importance that not only do we need to be aware of this problem, but we also need education and tools to be able to prevent it. So quickly, why does this happen? Well, it happens for a number of reasons. We've talked about a few of them. Misconfigured Git repositories, secrets buried in the history. We have to understand that just because it's not in our current version doesn't mean we can't find it. It could be on an obscure branch. Secrets exposed in logs or generated files, including sensitive files like env in our repositories. And also, we're just seeing a lot of people actively managing secrets in Git repositories, not understanding how big of a problem that is. So let's have a look at our experiment. So about 20 minutes ago, we leaked a credential into GitHub, public GitHub, github.com. This is how many times people have tried to exploit it since I've been talking. Now, I do want to clarify a couple of things. A lot of these IP addresses will be the same. They'll be initially making a ping to try and find information. So if we open up one of them, we can see that this is from Germany, and they're trying to find the account attributes. While other people will probably be looking at different calls. So here, they're trying to get the caller identity. So they may be initially trying to find caller identities and then get more information as they go. But a lot of these will be unique. I see at least 3 countries here. So in just 20 minutes, a whole bunch of bots really have tried to exploit this secret. So this just goes to show that if you leak a secret, even if you catch it quickly, even if you're aware of it and go back and remediate it, people still probably have found it. Now, I'm running out of time. I'm getting to the end, but I just want to make a kind of a quick word before I close up on how to prevent this. Well, we need to use secrets management systems. That was something that I think Lewis brought up as well when talking about Kubernetes. We need to have good secrets management to be able to prevent this. There's big tools like Vault. There's key management systems that you can use if you're using cloud services. Understand what tool is going to be right to use. And here's the key. Make sure it's usable so you actually use it. Never store secrets inside your Git repositories. I know it's tempting. I know, because it's a great way to share important information with everyone, but we never should do it. We have to make sure that we're using environment variables or other methods that we're not hard-coding them. Use short-lived credentials where possible, or even better, dynamic credentials so that they're being generated just in time. So this means that if a credential is exposed, you've set up a policy or you've set up a routine of rotating them so that it will not be a threat anymore. Restrict access. The last one, or the fourth one, restrict access to certain areas so that even if a credential is leaked, that means that not anyone can use it. They have to be coming from a select IP or a select area. And then finally, we need to add automated secrets detection. So there's lots of different ways to detect secrets. GitGuardian is who I work for. We have automated secrets detection, but we're not the only ones. There's open source projects out there too. Of course, I think GitGuardian is the best because I'm biased. But the important thing is we need visibility. So whatever tool is going to work for you, then that should be the tools that we're using. So that's it from me. If you want to learn more about the research that I presented, here's a random QR code. I promise it won't do anything malicious. But this will take you to a report called the State of Secrets Sprawl report. It will provide more information about what I talked about. So if you want to learn more, you can find out about that. And I have a link down below, or you can follow me on my social media handles. But I would like to thank everyone for putting this together, and thanks for paying attention. It was really fantastic to be able to present to all of you. Even though I can't see your faces, it's still great to have the opportunity to be able to talk about this to everyone. So thank you.
That was fantastic, Mackenzie. And I'm sorry, but based on past sessions, I don't think I can really trust you to scan that QR code and believe that it isn't doing anything malicious.
Do you know what? I don't blame you, but the URL is a little bit long. I think I'm always amazed that even in like security conferences, people will still scan it. So I'm gonna still put it up there to see what happens.
It is convenient, but that's sometimes how things go, right? When it's convenient, that's how you get caught.
Exactly. Yeah.
So I had questions coming up, but you were always answering them in your presentation. So props to you on that. I guess the only one I would ask that maybe, I don't know if this is really a question to be asking because it's not necessarily something that's going to solve the problem, but like, are there any consequences for the folks that are doing malicious things when they're exfiltrating they're getting these keys and that kind of thing? Is there something happening in the world right now to like cause maybe deterrence for people from doing something like this?
There's not really that many deterrents for doing this because keys are so widely used by different people. It's it's hard to even know who the attacker is. So we can find out their IP address, but that's probably not their computer. That's probably a service that they're using. It's probably obfuscated a little bit, so it's hard to track down. the onus, unfortunately, in security is on us. And not the bad guys. And hopefully there will be a change in that. But, to talk about how ridiculous actually, this problem is that there was a developer working for DJI that leaked a credential. That developer, right? It was an honest mistake, and it happens to everyone. And most companies would never do this. Most companies understand that this happens. But DJI had some reputational damage because of that. And then they prosecuted their employee, that developer, for leaking a secret, which is terrible. So, we need to change the game a bit. We need to be able to have more kind of consequences for that, because at the moment we're focusing totally on the wrong things. We're humans. We're gonna make errors. It's just how it is.
Yeah, absolutely. Eric, anything to add?
It's just like a fire hose of information. It was awesome. I was curious if maybe this is in your report or you have an opinion. What about things like sealed secrets, where you're encrypting your secret data in Git and then you're having to decrypt it after the fact? Any experience with that? Any thoughts?
So, like there's the security line that you should take, and the security line that you should take is that you shouldn't do that, because that sealed file, so you're encrypting it, is still going to sprawl everywhere and it's going to create risk. The security line is that you should use something heavy and complicated like Vault, and you should if you're a large company. I have a different opinion. So I have an opinion that we need to be using secrets management, but we need to use appropriate secrets management for where we are and the risk that we have. So, if you're a team, if you're a small team, if you're working on some local projects, as long as it's using good encryption, it does increase your risk because it sprawls even though it's encrypted. But if we can rely on that encryption and we can make sure that we don't leak those keys, then it can be a good solution if the alternative is that you're just going to share the secrets in plain text, right? Because secrets management can be so heavy. So I'm not so against that if it's appropriate for your, if it's appropriate for what you're doing. If you're a large company, you shouldn't be doing that because you're a target. You should be using these heavy, great software, but they can be expensive. They can be hard to set up. So yeah, I mean, I kind of get that, and I think that because it can be so complicated, I mean, that's infinitely better than just storing them in plain text in Git. So if that's convenient for you, if you're actually going to use that method, then sure, that's a step in the right direction. And as long as you grow with your maturity, then I think that's a fine first step. But the official line is no, don't do that. just to cover.
All right, one last question for you, Mackenzie, before we let you go. And this one comes from Nicholas over on Hopin. They ask, are there any tools suggested for scanning Git history and Docker images to list/hash all found secrets to use during remediation and ensure rotation?
Yeah, absolutely. So I work for Git Guardian, so we're a tool that does that. We're free for developers or anyone with less than 25 developers in their team. We'll scan your entire history. You'll have a nice dashboard. We also have some open source tools for it. So obviously, that's the tool that I recommend. And we can also scan, Docker images and all these areas. So Git Guardian, for sure. But I always like to mention some other areas. If you kind of were looking more at open source projects, there are some great open source detection tools out there. They don't work in that large scale enterprise things because they can get pretty noisy. But if you're just wanting to experiment with secrets detection, Git Guardian's free, but there's also open source alternatives out there as well. So if you do a quick Google search, if you look into it, you'll find some great options and ones that will fit into your workflow, I'm sure.
Excellent. Thank you for that answer as well. And thank you for a wonderful session, Mackenzie. We're going to let you go. Have a good rest of your day, and I hope to see you around again soon.
Awesome. Thanks, guys. It was great to be on part of it.
Thank you.
All right, Eric, we're in break time. We cut into the break a little bit, which I think is fine. It was great to have some extra questions from folks. And we got about a 5-minute break, folks, before the next session. So feel free to get up and do some more stretches if you'd like, in case you didn't fall over. I saw Kyle before that last stretch broke Kyle and is now going to be suing. So apologies about that. But if you're still willing to do some more stretches, folks, feel free to do that now. In addition, I want to remind everybody about something else that's going on throughout this, and that we have nominations for the DevSecOps Awards. Did you know about that, Eric?
I had heard about it.
You did? Okay, good.
We have a slide for that.
Oh, look at that. So you can go to devseccon.com/community/awards and nominate folks in the community that you think should win, that you believe fulfill the award categories we have here. We have Inspiring DevSecOps, the individual award of 2022, Most Effective DevSecOps Team of 2022, and last but not least, Outstanding DevSecOps Community of 2022. So feel free to head on over to that link, provide your nominations through the form there, and winners will be announced by the end of the year, I believe, right? That's what we said. Yeah, announced later in the year. So check that out. That sounds like a fun. I'm excited to see who wins. Any guesses on who it might be, Eric? Are you going to get the individual one?
No.
No. Well, I find you inspiring, Eric. So I'm just going to say I think you're worthy of.
Well, it's because of my orange shirt, my rare orange sneak shirt.
Yeah.
It was interesting. We've had a couple people bring up the CodeCove exploit, and it reminded me while you're over on DevSecCon.com that we have a podcast. If you're not familiar with it, we have a podcast that often is hosted by our Sneaks co-founder Guy Pajarni. And if I can get my screen share going, let me show. We actually had a talk. Can't talk and click at the same time here. We had a podcast with the CodeCove crew last year, and I remember this one because it was very interesting. They're very transparent about what happened, and went through it all. In fact, one of the great things about security, software security companies in the supply chain arena, they all seem to be very willing to share when there are stumbles and when there are things that help us all learn. There was another issue where Argo, self-promoting my own blog here, but there's a link in here to their blog. That's why there it is. Argo had an issue, CVE, in their software, and I thought this was a great article. They go through how it was found by the security analysts that found it, and how they worked with them, and how having automation around security helped them to really deal with it quickly. Just really good examples of good stewards of what they have in the supply chain arena.
Yeah, and I recall Argo having a talk back at our Big Fix event too, which was fantastic as well. Good stuff. Good stuff. All right. Without further ado, let's go ahead and jump into our next session. What do you say, Eric? Does that sound good to you? All right. So next up, we have Robert and Corey. We're going to be talking about, in a full session this time, about hacking and defending APIs. I'm going to let them introduce themselves because they have quite the impressive backgrounds as well. So let's bring them on. Rob and Corey, good to see you both. How you doing?
Good. How are you guys doing?
Doing well, doing well. So you're going to be talking to us?
Yeah.
Oh, go ahead. Yep. A little latency on the internet, Corey, you're going to say something?
I guess I'll just go and introduce myself. My name is Corey Ball. I'm a senior manager of penetration testing over at Moss Adams, and I wrote the book Hacking APIs with No Starch Press. The book is out with them now, and then the major retail release is a month from today.
Nice. Awesome. How about you, Rob?
I'm Robert Wagner. I'm a field CISO for a company called Fletch. They actually integrate with things like Sneak and use a natural language processor to go reading through thousands of articles and then see if any of them are relevant to what you just found in Sneak. So,
wow, that's amazing. Nice. So I think what we're going to do is Eric and I are going to get out of the way and let you both take it away from here. Sound good?
Sounds great.
All right.
All right. We're going to be talking through hacking and defending APIs.
So just a quick little additional background. So I'm also a founder of Hack for Kids. We are a charity that teaches kids about internet safety, security, and ethics. I'm on the board of my ISSA. As you can tell, I love dogs and motorcycles, and even taught a dog to ride motorcycle with me. I actually spent about almost 20 years now in InfoSec. As you knew, I said I was a field CISO at Fletch. That means I acted in an advisory capacity for other companies to improve their security, regardless of you're using Fletch. But we do have a free tool that you can actually use.
And I'm Corey Ball still. The only thing in addition to what I've said already is that I'm an evangelist over at appysec.ai. I help spread the good word that they have a tool that is excellent for scanning web APIs for vulnerabilities.
That's a really cool scanner.
All right, this is an overview of the API Security Top 10. This is what we're going to be discussing today. And we're going to go into this from red team perspective and Robert as the blue team perspective, and just some of the things that I look for when I'm penetration testing APIs and attacking them. Robert will be discussing some of the fixes that can be applied or maybe a mindset that can be applied to help remediate some of these findings. First up, we have API 1, which is Broken Object Level Authorization, also known as BOLA. This is number 1 for a reason. It is the most prevalent vulnerability that's out there with REST APIs. BOLA vulns are present when an API provider allows the consumer to access resources that they should not have authorization to access. So when I'm attacking an API, typically I'll set up a user A account. I'll go through all of the actions that I can take as that user. And then I will create a user B account and go back through and try and find user A's resources. So here's some typical types of requests that you could see where we're doing a GET request for resource 1, or maybe a user ID number, or maybe a combination of something like a user account number and then a company name. And I'll just go through, make all those requests as user A, replace the token with user B's token, and go back in and see if I can get any positive responses for those same resources. It's not the fact here that the API provider is using sequential IDs for resources, although that makes it a lot easier for an attacker. It's more of the fact that there are not authorization checks going on the back end that are validating that I am only accessing resources that I should be able to access.
And so as being a blue teamer my whole life, my job has always been to try and make Corey's life as miserable as possible, right? And it's not easy here with BOLA. BOLA is not easy to defend against. A lot of people confuse the difference between authentication and authorization. So just because you have authentication, maybe you have an API gateway or something, maybe even your API firewall, that doesn't help here, because once you're logged in, you can start messing with the parameters, just like Corey explained. So to defend against this, first off, you need an access policy if you don't have one already. And then you're going to have to design authorization in the same way a domain admin would design authentication within their realm. So you're going to have to go down literally to every attribute and make sure that groups then have the correct access to those attributes, right, to those API paths. Then you're going to need to require that all access be based on that authorization, and then deny everything else. Now, testing for this isn't necessarily hard. You can start building those tests out in something like Postman. But if your testing isn't automated, it's going to be time consuming, especially when you're looking at thousands of endpoints. So to start looking at how potentially to test that, take a look at OWASP ASVS and NIST 800-162. They're not perfect for this, but they will give you some great guidelines.
API 2 is broken authentication. And this is a catch-all for all API authentication-related vulnerabilities. So I separate these out into 2 categories, which is like the classic vulnerabilities, maybe something like no authentication or a weak password policy, and then the more relevant vulnerabilities specific to API. So weak JSON web tokens, exposed private keys. As an attacker, what we're looking for just like the last presentation, we're going through GitHub repositories and we're looking through those for any exposed information. We're also looking at the API from using an attacker mindset. So if I'm requesting information from an API that doesn't require authentication, is there any private information that I can request from it? If so, there should be authentication. Yeah, that about does it. Robert?
Hey, yep. Sorry, I actually lost the audio and video there for a second. I'm back. So even though we said authorization is the most common, that doesn't mean you can get away with not having authentication, right? It's good to have. Get a gateway set up. This Vector is all about the authentication flows. So first thing, get MFA already. If you don't have MFA in your organization, get it and put it everywhere. If you buy nothing else this year, MFAs cures so many evils, not just in this space, but so many security domains. If just like encryption, don't let your devs roll their own auth. That never works out well. There's plenty of libraries that are already created. Remember that we're talking about authentication flows, and that includes things like the I forgot my password mechanism. Corey can just as easily abuse that if you don't have good checks there. OAuth and API keys are not going to prevent Corey from executing this attack. And when you're not sure, brute force attack your own systems. See if you can get in various ways. If you have the time. If not, hire somebody to do it. Corey's really good at doing that.
API 3 is excessive data exposure. So excessive data exposure takes place when a consumer makes a request for data from an API, and the provider sends the whole object back over. And they're counting on the consumer to filter out the data themselves rather than doing that on the provider side. So here, this is a typical request for maybe this user's account. And you would expect as a response to get the ID, first name, last name, maybe the privilege level of that user. But you wouldn't expect to also get maybe the representative or the administrator of the account, their information along with that. So that's something that should be filtered out before it's provided to the consumer or the client. And excessive data exposure is more about what can be done with the data than it is about sending too much information. So if it also included their address or something else, those are things that you would expect to be with that user potentially. But this other information provides us with an administrator's full name, an administrator's ID number, their email address, and the administrator's multi-factor status. And we can see that's false. So we can leverage this in additional attacks. If we're going after an API, admins are targets that we're looking for, and knowing that one doesn't have multi-factor authentication is going to be great to attempt and compromise their account or guess their password.
Yep. So defenses here are all about the streams, the data stream in this case. But this flaw usually comes about because people wanted to get things done quickly. They wanted to make it work. So they'll do things like just send all the data, right? So they might do something like if you're requesting data from a security cam's API, instead of just sending you the one camera, it sends you all the cameras and expects the client's filter to filter that out. That's bad. OWASP has told us this forever. Clients should never be allowed to enforce any security policy. Ever, not ever. So do things like check for sequential IDs, which can be guessed. Make sure that the data coming back is not more than the user is authorized for. If the data has PII, you now have to take this to another level, a higher level, and classify that data, apply policy to that. But always, always, always just be thinking of concepts of least privilege and provide that for your access. Then teach the devs how to think that way as well. And then a lot of evidence of these things happening can be in the logs. So check the logs.
API4 is lack of resources and rate limiting. The API is not sufficiently protected against excessive amounts of requests or payload sizes. This can go a few different ways. So rate limiting is one of the key functions that's used to monetize certain APIs. So bypassing this restriction can have financial impacts on that end. And if one user is able to bypass that rate limit, then you're sure that the rest of the internet is quick to find out as well. If the affected infrastructure doesn't have enough resources, then a certain amount of requests could cause a denial of service. That's not too common. What's more common is that the infrastructure would scale with the amount of requests, and having that just sort of run amok isn't a financially sound decision. If there's something simple like rate limiting that could be put in place to prevent that sort of thing, it should be. The other aspect that is greatly affected by rate limiting would be to reset a password or use that functionality within the API. So if a user is going to guess the reset code in something like this request, then if it's 4 digits, that could be every potential combination could be guessed in 10,000 requests. And if there's no rate limit, then you can just send over the 10,000 requests and successfully reset the password if there are no other security controls in place. But if there is rate limiting in place and it allows maybe 100 requests per minute, then I can just send over 99 requests per minute until I've guessed the code as well. So the rate limit has to be enforced, it has to be strict, and there should be other controls in place for something like a password reset. There are also methods that can be used to bypass the rate limit altogether as well. And so here you see an example of case switching, where I've just put an uppercase A and an uppercase U, and that's still processed to go to that endpoint and to guess that reset code, but it's not counted against me on the rate limit. And so if I could do something simple like case switching or adding a question mark or adding a null byte with case switching, then I'm going to use that tactic in order to bypass any rate limit restrictions to guess that reset token.
And that's a great example of how hackers think, right? They're constantly looking for, hey, if I just change this a little bit, can I get away with the evil that I'm trying to get away with, right? And Corey's very evil. No, the good thing is that for things like this, there's plenty of ways to defend against it. And your SREs are probably aware of most of them. Docker has built-in limiting functions. There's plenty of ways to throttle requests, responses, the amount of data passed. So put those in place. And then on the back end, again, logs are your friend. In fact, just about every logging tool out there has some sort of easy way. We're talking even the free tools, right? You can get Elk, whatever. But standard deviation is easy to compute in all of these tools. So just looking for something like plus or minus, well, actually, in this case, plus 2 standard deviations might give you a heads up. And if you really want to get fancy and start using some algorithms to start modeling that data, free tools like SciPy or our project can help you out when you're ready for that next step.
API 5 is broken function level authorization, also known as BAFLA. This is a similar vulnerability to BOLA, except instead of an authorization problem with requesting resources, it's actually an authorization problem with privileged actions. So in this instance here, there's a put request to update this account. User A should be able to update their account, and user B should not be able to delete user A's account. If we're talking about something like a fintech API, BOLA is where I could request information about Robert's account and get back information, maybe his account balance or account ID. BAFLA is more about being able to transfer Robert's money into my account.
Not that you'd ever do that to me. So yeah, Baffle is pretty bad. This is all about, Corey being an imposter, being admin or admin-like when he shouldn't be, and doing those actions. So just like Bola, we need to have an access policy to help stop those imposters. Again, everything needs access needs to be controlled right down to the attribute level, especially on things like money transfers. Deny everything else. Enforce only on the server side, not the client side. The same concepts apply here. Test to make sure that's working. Try to act like a hacker and do things like Corey just described, where you're doing transfers on somebody else's account. Again, logs for the win. In this case, you might want to look for things that are rare, and most logging tools have the concept of looking for things that are rare. Basically, you're going to be looking for rare methods to an endpoint or rare calls from a particular account. You won't prevent the attack, but at least you'll have some visibility that things like that are happening.
API 6 is mass assignment. This is the binding of consumer input to data models without filtering properties. In other words, a consumer can pass additional parameters to an application that are automatically added to the internal object. This can take place if developers are depending on obscurity as one of the security controls, or if the user input isn't sanitized or filtered. We see this a lot with account registration processes. And here you see an attack where a post is being done to this account registration. And typically that request would only have maybe username and password and the email address of the user. However, the API provider does have some process to create administrative users, and they are using certain parameters to represent that privilege level. So if the user input isn't filtered out, I could try and guess what they're using on the back end for that, or maybe I could use administrative documentation if that's public, and focus my attack more on just the typical parameters that are used. And I could just send those over in a single request. If there are restrictions on the size of the request, I could just send over a bunch of requests trying to guess, admin true, admin is 1, is admin true, all these sorts of things until I get some sort of success.
So Corey's just playing here, right? He's looking for clues in what he sends and what he gets back from the API that can tell him about properties that he might be able to manipulate. So all the previous suggestions still apply, right? We're going to, again, make sure that authorization right down to each API's level is what we're applying. Otherwise, you're going to be left with either disabling mass assignment completely, which would probably break a lot of things if you're already set up to allow those, or really what you're going to have to do is do exactly what I said, go back, find out each parameter, and then restrict in each API to only allow those kind of things if you're authorized to take those actions, which is going to be the better choice.
API 7 is security misconfiguration. This is another catch-all for all generic security issues. When it comes to tooling that's available out for vulnerability scanning of web applications and APIs and different systems out there, all of those are really good at catching security misconfigurations when they're set up generically. They're not so good at catching other vulnerabilities on the OWASP API Security Top 10. So a security scanner, maybe something like Qualys or Nessus, or even OWASP Zap or Burp Suite. From a generic perspective, if you're just feeding it the web application link, or maybe even the URL to the API, then it'll catch some things like SSL-related issues, verbose error messaging, verbose headers, but it's not going to catch BOLA vulnerabilities, Baffle vulnerabilities without additional configuration. So these are fairly straightforward to find and take advantage of.
And they've been around forever, right? We're all familiar with everything from directory traversal to verbose headers. It's been around forever. Corey loves it because for him, there's always an opportunity that something's going to go right. But for us defenders, this is really Murphy's law as far as API security goes. Literally anything that can go wrong will go wrong. There's no way to plan for everything, but you should have a plan, right? You should be doing things like patching, updating, and hardening. But if you forget, oops, there's a way in for Corey if he discovers it. The best way to approach this is just like you do with IT ops, IT security. Put in a change management program, a compliance framework. Yes, all the boring stuff that we all hate, nobody wants to do, but you've got to do it. And then enforce those things. At least you're limiting the amount of things that can go wrong.
Speaking of being around forever, API 8 is all about injection. Injection flaws that have been around web apps for the past 20 plus years were just ported over to APIs. So SQL injection is still around. We also have NoSQL injection. In the right cases, you could see cross-site scripting where you're able to inject information through the API into the web application, and then it's loaded with the web browser and then executed. Also, system command injection. The way we typically go after these, we're looking for requests that allow user input, and then we're fuzzing the input that's allowed to see which type of injection is successful. So if we send over a bunch of SQL injection attempts, then we're going to review the responses to see if there's any indication that a SQL database is in use, or there is some sort of maybe delay in the response if we're doing a blind SQL attack, and then we'll focus in the attack more from there.
So yeah, seriously, 20 years. This has been the bane of our existence. Sorry, bad pun. But I mean, we've tried so hard. We tried when web apps first came out. With all sorts of ways we've tried to take care of this by building perhaps libraries that devs can cut and paste, and it's still around because nobody tends to those things. But for the first time in maybe 20 years, maybe we've got a chance, right? The CI/CD pipeline can be instrumented and automated in such a way that the devs can run their own checks. So the best way to defend against this is to test early, test often, create those tests, and do it during dev, do it during test, get it before it makes into production, automate it if you can.
API 9 is improper assets management. So with REST APIs specifically, a lot of time versioning will be included in the URL. So you'll see targetname.com/API/v1, v2, v3. This vulnerability is all about unsupported versions of the API. In and of itself, you're not going to be able to, find out that API 1 is still in use. Therefore, you've owned the whole application. But instead, this is normally an indication that that version is not supported anymore, like an unsupported software vulnerability. So you have to find this vulnerability, which is often the gateway to other vulnerabilities. If there's a test version or a UAT version that shouldn't be publicly exposed, then we're going to go back through that version of the API and test for the previous vulnerabilities. We're going to test those for BOLA and BAFLA and injection. We're also going to go through the GitHub repository to see, is there any public information available about the current version of the API, maybe some of the issues that were involved in the past version of the API. With the great resignation that's still going on and developers switching careers and everything, I think this is one of the vulnerabilities with APIs that could be overlooked and could be very important for times to come. And if you have that developer that's maybe responsible for an aspect of V1 or V2 of the API, and they're no longer with the organization that's providing the API, then the rest of it could just move on and progress and be updated while this one version is no longer supported. So this is really important to make sure that the versioning is updated consistently across the board, and that previous versions are no longer available.
And really, this is just asset management all over again. Instead of your assets being servers that need to be patched, we're talking about APIs, their versions, and their endpoints, right? So first thing, you've got to document your APIs. Yes, all of them. I can't tell you how many times Corey and I have talked to someone who doesn't have any of their APIs documented. And that's just a recipe for disaster. So enumerate them. Katie Paxton Fear has an awesome tutorial on how to use Kite Runner. It's a free tool that can go through and enumerate your APIs. Check that out. Implement robust change control and asset management processes. And again, all of this can be automated right in the CI/CD pipeline. This doesn't have to be a burden on anybody. You just have to put the infrastructure and automation in place.
And just like any other OWASP top 10 list, number 10 is insufficient logging and monitoring. Without logging and monitoring and alerting, an attack can run rampant and go unnoticed. There will be little to no chance for attribution, and you won't know how they compromise the API altogether.
And seriously, logging solves so many problems. It's second probably only to multi-factor. You got to do it. You got to get your logs out there. If you don't start logging, I'm just going to show up at your place and actually make you walk all over the Legos using this presentation. Barefoot. No, logging's easy. There's free tools. Just do it. And it'll solve, well, at least it'll help defend against a lot of problems. We've got about 3 minutes left, Corey. Oh, okay, cool. So we can go ahead and take questions, I guess, with the time we have. If we skipped some stuff, Corey and I have some other great suggestions, but we didn't have time here. You can contact us via our LinkedIn or Twitter accounts, and we'd be happy to do that. We're going to make the deck available too, aren't we, Corey?
Yeah, that's right.
All right. And with that, any questions?
Well, one excellent presentation, both of you and Corey, Rob. Appreciate that. The different perspectives you all were taking and having that type of style to it was really, really interesting and helpful to get that insight that way, especially for me. That's fairly new to some of the stuff that you're discussing. So,
oh, cool.
Yeah. So far, I don't see any questions in the chat just yet. Jesper just shared in the chat saying great talk. So
thank you,
another round of applause for you there. I did like your lots of people were calling out the references to Final Fantasy, the Star Wars, Legos. So lots of props.
Awesome. We want to make
it's all represented back here as well. We got Final Fantasy, we got Nintendo, and Star Wars.
Yeah, Corey, I really do. I mean, I want to save time here, for questions about your actual presentation, but I'm super interested in the background and your setup and stuff like that. So maybe I'll have to talk to you offline and geek out over that stuff. But yeah. So I guess, well, the question that kind of came to mind for me at least, and Eric, feel free to pop in when you have a question too. I think it was API 8, the injection one, right? And then Rob, you're mentioning that that's like 20 years still. I guess my question to you is more of like a feeler kind of thing. Do you feel that there's ever going to be a point in time where it's not as prominent of an issue and it's no longer this 20-year long, 25, whatever it may be, type of situation that we're dealing with in this space?
So we'll never get rid of it completely, right? But I think the best way we can get there is to get tools in the hands of the devs that probably just get built right into the build, right? The build kicks off, it automatically calls a sequence that tries to do some basic SQL injection, and check for all the low-hanging fruit. And then once they get the go-ahead, being able to just go to the next step of their build and publication would probably be the most efficient way to do that. And take the time to teach the devs, like show them what a SQL injection looks like. A lot of them have never seen someone abuse their app with SQL injection, right?
Yes, you're preaching to the choir right now. And past roles that I've had, our security team was very hesitant to educate us as developers on like what it is that we need to defend against. And if we don't see it, how the heck can you expect us to just blindly know what to do? So
exactly, security should be the bridge here. We need to take our devs out for a couple of beers and run them through Juice Shop or something like that and show them what happens.
For sure. Eric, anything to add from your end?
No, I mean, I was thinking about the injection piece too, and I was wondering maybe there's something we can do around, what Jonathan was talking about with CI fuzz testing and have automated injection. Are you able to pass interpolation strings in that, to catch things like what Log4Shell was doing and all that kind of stuff. So a lot of stuff. But the one critical piece that I'm going to have to get with you offline, Rob, is how do you get your dog to ride a motorcycle?
So I am quite an accomplished amateur dog trainer. I will be happy to step you through that process. It was a lot of fun, actually. I had him riding in about 2 weeks.
Oh my God.
Tiny little steps. Yeah.
That's amazing.
Fantastic. Well, before I let you go, Rob, also, I want to let you know, you can make me walk across Legos all day. I am used to it. I have kids, so that's not that painful of a... I'm sure, Eric, you can attest as well.
Damn, you're immune.
I'm immune. Corey and Rob, thank you both so much. Really excellent talk, and hope to see you around again sometime too.
Awesome. Thank you guys so much for having us. It's been great.
See ya. All right, let's jump right into the next one. See if we can get right back on time a little bit here. It's all my fault. I read the run sheet wrong, so I apologize. But without further ado, who do we have next, Eric? You want to intro?
Joseph, and I am not going to ruin your last name, so I'll let you say it. But he's just going to come talk to us about security as code, DevSecOps approach. Joseph's with GitHub Security Labs. Runs this YouTube series called Security Bites, along with a bunch of other stuff that I'll let him go over.
All right. Hey, Joseph.
Hello, everyone. Thanks for having me.
Thank you.
This session is going to tie it very well with what Rob said about a...
I'm on the edge of my seat here.
Oh, no.
I think we lost him. I thought it was me at first. But then I saw you moving, Eric, and I was like, okay, it's not just me. Well, I guess we'll never find out.
Yeah, this is the fun of live, right? So
the fun of live, yeah. So there you go. Security as code. You just disappear. All right, let's see. We'll see if we can get Joseph back shortly here. But in the meantime, while some housekeeping, we have a question on YouTube from Alma. Corey's slide will be shared. Yes, Rob and Corey both mentioned that they're going to be sharing it probably on their Twitters. A reminder of their Twitter accounts. Corey's at happy_hacker. That's HAPI_hacker on Twitter. And Rob is at Mr_Minion, MINION. So you can check out their Twitter accounts, and I'm sure they'll post it and share it over there, or the slides. And I think most folks will. And I guess that reminds me as well, these are recorded, not going to be recorded. They are recorded, and they will be edited up. You can probably expect that at the latest towards the end of the week, and they'll be posted up on the DevSecCon YouTube account. So be sure to be subscribing over there, DevSecCon YouTube, to get all these sessions that you can go back and reference and learn more from them again. All right, I think we have Joseph back, yes? Yes, we do. Hey, how's it going again?
Yeah, I'm here. Can you hear me?
Yes.
Yes. You had us on the edge of our seats, Joseph. I mean, you were like, you just left off at just right at the opportune moment, and I was like waiting to hear what the answer was. So
I think he might have froze again.
Not again. How does this keep happening?
Oh, the anticipation. Just waiting for the buffer to...
Eric, I think it's you.
It's me. Oh, well, I guess I'll go.
No. Don't you dare leave me.
I'm jinxing it.
We'll see if we can get him. I'm going to remove the frozen image of him like that, because it's always funny. Like for me, anytime that's happened to me, it's like always in the most awkward position. I'll be like, like, and I'm just, my face is stuck like that, and everybody gets to just laugh at my embarrassment.
Third
All right,
time's
we got
a charm.
Third time's a charm. Joseph?
As soon as we add him live, it seems to be freezing.
Yeah.
That's weird.
I'm going to remove him again, maybe. Maybe it'll reset. Wow. Coming to you live over the internet. Huh. All right, we got him again.
Okay,
Joseph.
let's go.
Let's
Okay.
go.
Hi, everyone.
Right. Hey.
I'm sharing my screen now. Let's hope everything's gonna be all right.
Don't see your screen just yet. Here it comes.
Yep.
All right.
I'll just
Go
share
for it.
it.
Run.
Perfect. Okay, welcome to my session. I'm Joseph from the GitHub Security Lab. Thanks for the introduction. Indeed, I have my video series on YouTube where I try to educate developers on common software bugs, on how to avoid them. This is because I see many people on the security space trying to show how they can benefit from bugs. I try to show common vulnerability patterns and how this can be avoided. And this is part of the overall team, which is our mission is to secure the world's software that we all depend on, which is the open source. So we try to inspire the community to secure the open source software. And we do this through different ways. One of them is through research. In the past 26 months, we found 331 CVs by using something that I'm going to show you now that ties really well with what Rob said in the previous session on a way to integrate everything into the build and try to avoid injections and other attacks. Let's start with a story. So 10 years ago, when NASA sent Curiosity for the first time in Mars, just before the rover opening the parachute and start exploring Mars, there was this idea from someone in the team to code review for one last time the code for the parachute to open. And they noticed a vulnerability. So here the vulnerability they spotted was that in the signature of the function, there's an array that expects 12 elements, but an array of 3 elements is created in line 7. So this leads to random memory being accessed in line 2, which leads into random behavior and potentially the crash of the rover. The smart thing that the NASA engineers did was that they didn't just fix that specific vulnerable instance of that bug, but they wrote a generic query in CodeQL, which is the language I'm going to show you in our demo, to pick up instances, what we call variants of these vulnerabilities in other places of the code. And when they ran this query, they found 30 other variants that they could lead into the rover crashing into the surface of Mars. The smart thing that the NASA engineers did a year ago was that they shifted security left by integrating CodeQL into the pipeline. Team is using CodeQL, and you can benefit from this collective knowledge that we've built over the years by just turning CodeQL on, which takes 2 or 3 clicks in your open source repo. And if you are an enterprise, you need to purchase some licenses. But today's session, in this talk, I aim to show you how you can be an active user and how you can use it to tailor it in your code, to tailor it for your needs. This brings together security as code, which is a methodology that we got inspired from the lessons learned from DevOps and quality assurance. DevOps was successful in our opinion because historically developers didn't just had to open tickets to infra teams. They had security they had infra in their hands.
Looks like more technical difficulties are plaguing us. Sorry, folks.
Yeah, let's give Joseph just a couple minutes to see if he is able to reconnect. and we'll go from there. But yeah, unfortunately, we're getting kind of plagued with some of these technical difficulties today, huh, Eric?
I blame that internet thing. It's a fad.
Oh man, it's such a fad. All right, Joseph's back.
I apologize for the connection. I'm in a hotel in We Are Developers Berlin, and while it was reliable in green room, now it seems to going away a bit. So
no
the
worries.
methodology
Take it away.
code that I was just discussing with you, under which security experts are gonna codify their knowledge and provide it to developers in the organization under executable, readable form, so that developers can understand what they are doing and can also modify in order for security to be a seamless observer of the day-to-day DevOps instead of being a stopper. So in this way, we expect developers to continue in their same speed, and security as code is gonna only alert them when there are problems with vulnerabilities. And in our demo, we are gonna execute and realize security as code by using CodeQL, which is a language under which someone can query code as if it was data by describing what we want to find instead of how to find it. CodeQL is free for open source, and it supports languages right now such as JavaScript, Java, Go, Rust, C, C++, Python. CodeQL is declarative, which means that we are going to describe vulnerabilities, and is also logical, under which we can use operators like and or to form connections. So behind the scenes, the code base is becoming a database, a relational database in the form of an abstract syntax tree, in order to find these complex connections that can lead to vulnerabilities. In our demo today, we are going to find an SQL injection that, like Rob said before, is a form of injection that exists for 20 years. In the meme on screen for XKCD, we can see that there was no input sanitization. So behind the scenes, the developer was expecting the user to just provide a student name like Cleo here, but in reality, students, or creating an admin account for a hacker by just closing the quote and passing another command through a semicolon. So the plan for today's demo is as follows. First of all, we are going to find sources of vulnerabilities by describing what we want to find. In the example from the XKCD, the source is where the student name is expected to be going to the database. And sinks are places in the program where the vulnerability is being executed. The vulnerability only exists if there is data flow from sources to sinks. Otherwise, if there's no data flow, you have an unexploitable flow. And we are going to do this through CodeQL. So I'm going to switch to my demo now, where you can see, first of all, the intentionally vulnerable code base from the OWASP. Security Shepherd. In line 98, we have our source, which is the place in the program where a username is being passed into this vulnerable application. Think about the normal Android app where there's a username and a password being asked.
I think we might have lost Joseph again. Unfortunately, the internet connection where he's at is just not proven to be stable and sustainable right now. I like the way Lacey put it in the chat. We call them demo gremlins. What do you think about that, Eric? I like that. You're muted, bud. Hold on. I can't unmute you.
I have other words for it that I can't say on a family show, but yeah.
Demo gremlins. That's a good way to put it.
So Brian, you're more familiar with the platform than I am. Would it, since we have limited Wi-Fi where he is, can we do voice only with screen share without the video? Would that maybe help?
I don't. Yeah, we could try that. We could give that a shot. Joseph, I see you're back. Be sure not to share the StreamYard, the link there that's on your screen right now before we add you on there, but we can see you.
Okay, perfect.
And then I'll add you back in here. Okay, let's try it that way now. All right.
I turned my camera off as well. So I was saying that here I imported Java standard library in order to benefit from code reusability. The source of the vulnerability is here. So it's where there are some trusted user input getting into the database. And by this, I want to access all methods in the program first, and then I want to arrive in those methods that are receiving untrusted user input. So I'm not going to use the where clause at the moment. I'm just going to use a from and a select. So by this query, which looks like SQL for now, I'm expecting in my screen to have all the methods being accessed in the program. So far, so good, but that's not so helpful because I want to find those that are the pain points. If you thread model, you want to go to those methods that are receiving untrusted user input. And for this purpose, I want to reduce down my results into just those that are receiving untrusted user input, specifically the getText method. So here, if I come and I reduce it further, I want to be very specific with CodeQL, has qualified name, and I want to describe those methods in the program that are receiving untrusted user input. So this way, we model the source of the vulnerability. And if we run this query, we expect to have those methods that are receiving untrusted user input. We don't know yet if they are vulnerable. We are going to find later. Now, let's go back to the vulnerable code. We need the sink of the vulnerability, which is a place in the program where the malicious query is being executed, which is the raw query method. But if we want to be more specific to avoid false positives, that is a main and the pressing pain for security teams, we want to find the first argument in the raw query method. If that first argument is being set, we know that we have a sink. First of all, I want to find all the occurrences of the raw query method, which is here. But I want to find, as I said, just if the first argument is being set. So I'm defining another variable, and I'm going to use a logical equal here to say that I'm only interested in the first argument of the raw query method. If that first argument in the raw query method is being set, I know that I have sinks of vulnerabilities. So far we found sources and sinks. What is missing, as discussed in the plan, was the data flow. If there is flow between a source and a sink, we have confirmed SQL injection findings. I didn't write this code here. This is a ready-made template. Maybe the NASA team wrote this, maybe my team wrote this. What is important for you is that you can do the same. You can benefit from templates, and you can start from a point where you are using the collective knowledge that we've built over the past 10 years to model for vulnerabilities. So if I explain the code here, at the top, we have some metadata that are going to help us in the modeling of the SQL injection vulnerability. Here we are importing some libraries that are going to help us with following taint around the code to see if the untrusted data flow passes from specific points. And here we can see the class keyword and the extents, which shows the real power of CodeQL, which is an object-oriented Here, predicates are reusable functions and are overridden in the template. We are going to use the code from before. Here, we want to say to CodeQL that there exists, and I'm going to introduce another keyword now, which is exists. There exists a method access. We can call it call, such that when this method access is the get method, we want to model a node, that this node, which is an expression, is the source node. And when there's flow from the source node to the sync node, that we can model in here as well, we can say that there's another method being accessed, call. This specific method is the raw query method. And when the first argument is being set, we know that there's an SQL injection vulnerability happening. So the true power of CodeQL is going to be shown when I run this query here. If I run this, I expect to come up with confirmed findings. So as we can see on the right, we have two confirmed SQL injection findings. First of all, the first path is from the getText method on the left. It then flows to the username that is being checked on whether the username exists in the database through the login method here, which is finally passed in the query. But there's another path in the same vulnerability, which happens when this same username is checked from being false. So I want you to compare lines 102 and lines 116. So in my experience and in my team's experience, when security professionals or people who do code review, like developers, are trying to find SQL injections or in general try to fix vulnerabilities, they often fail to see every path that a malicious user input is passing by. And in this way, we can find confirmed findings of where untrusted user input, like the password here, in another instance of the vulnerability is being checked for an authenticated user, being passed in the login method before it's being executed. And then you have the same for the password. So to summarize here, because I was being cut before, with CodeQL, you can describe what you want to find. Like, for example, I described the pain point in my code, which is where untrusted user input gets in. Then I described where this input is being executed, if ever. And this was the sync of the vulnerability. And I connected the two by using a template, which allows me to write faster, be more productive, and in general, build on top of the collective knowledge that people in the past have used to build with CodeQL. So if you want to start your journey with CodeQL, like I said before, it's free for open source, and you can learn more by using the URLs here. And finally, my team has introduced what we call community office hours, where open source maintainers can come to us and they can discuss some of their security problems or their security interface. They often come to us and they don't know what they don't know. But through our conversation, we've seen people in the open source world maturing and improving their security posture. So thanks for your time today. Apologize again for my connection. I'm in a hotel in Berlin. Everything in testing was working correctly, but the demons of demons were with us there. Thanks for attending my session. Thanks DevSecCon for having me. If you have more questions, you can connect with me at JKCSO or follow my team at GH Security Lab, where we publish our vulnerability research. We publish free slots for our community office hours, and we are also publish our educational content in order for you to learn more about security and improve your code security so that we all avoid vulnerabilities and we serve our mission to secure the open source software that we all depend on.
Excellent, Joseph.
Sharing.
No worries, no worries. Don't feel bad about the internet connectivity issues. These things happen, man. So I'm sorry that it impacted the presentation quite a bit for you, but glad we were able to get you through it.
Thanks so much. I apologize again, and I'm more than happy to summarize now that the connection is more stable with my camera being off. So in this session, everyone, we've seen how security teams like the one of NASA have used what I've demoed, which is CodeQL, in order to secure their code in 2 different decades, in 2 different eras of software engineering. So in the past, they've used it to pick up specific problems very late in their production, when their rover was just about to land in the surface of Mars, and they had their parachute being unable to open. But a year ago, with another rover, Ingenuity, they did everything the way that we expect teams to work nowadays, DevSecOps, by using CodeQL in their pipelines. So through this example, I then introduced security as code, which is a methodology under which we expect security professionals to codify their security knowledge so that developers can read, understand, change it, and in general benefit from a security culture where everyone is aligned, everybody's is on the same line. Then in the demo, I've shown you how I could model a query to pick up an SQL injection vulnerability in OWASP Security Shepherd. What I've done was to find sources by describing how untrusted user input looks. Then I've described sinks, which I described how a query being executed looks in my code base. It could be a private code base. It could be an open source code base. And then I've modeled data flow. If the untrusted user input essentially ever flows to the point that is being executed. And by that, CodeQL gave me all the potential ways that the untrusted user input could end up into the sink, i.e. it being executed. While my demo was a bit basic with the flow being in 4 places, real code, enterprise code could have dozens of areas where untrusted user input flows from and to, which makes which makes hunting way more complicated in this environment. And with CodeQL, we've seen that vulnerabilities that are considered false positives are indeed vulnerabilities. So some FAQs I'm receiving a lot, since I have 2 more minutes here, is that, oh, so that's a SaaS tool. Yes, indeed, it's a SaaS tool. It doesn't have the capability of Dust. It doesn't run your code. It builds an abstract syntax tree that you are more than capable of exploring every time you commit your code, and tries to find vulnerabilities. But you are benefiting from this collective knowledge that we've built over the past 10 years. When NASA's engineers build queries to secure their code, you are benefiting from them. When my team, with the 331 CVEs in the past 26 months, is writing queries, when bug hunters in our community, in which we are trying to bridge the gap between security researchers and developers, are committing queries that end up in our code base, you are benefiting from those queries. You are more than welcome to go to your security tab in your GitHub project and click on security, code scanning, enable CodeQL. It's going to take you 2 clicks, and you are going to be a passive user. Today's demo, though, was on how you can be an active user, on how you can be a bit more tailored based on your specific code, and how you can build on top of all these pre-existing queries to pick up things that are specific. You can be generic by using keywords like any, like, for example, give me all the sources to all the sinks, and you don't need to be as specific as I was in the demo. So CodeQL is a super powerful tool that we've seen. It can change lives. It can change the maturity in your code, and can definitely solve the problems that the previous speakers spoke about. Like, for example, injections, that Rob said that it's still a thing even 20 years later. And he was asking for some tools that could be picking up the low-hanging fruits in the build process. And with this, I'm more than happy to receive questions from you. And I hope that I summarized the action that might be missed today.
Awesome stuff, Joseph. Thank you. Thank you so much for that. And I really do. I love that story about the NASA part of things and in there. So far, no questions in the chat right now, but I have one question for you that I find to be potentially interesting is in that sense of when people are being more active in writing the CodeQL code themselves, do you find potentially, or have you found folks potentially using GitHub Copilot to help them with that just yet? That other tool?
That's amazing. That's a great question. So I need to tell you an insight about that. So like 2 weeks ago, I was trying to get some, let's say, internal permissions to speak exactly about that because it's coming. So I don't know.
All right, well then let's pause there. Let's pause there because we also need to start wrapping up too.
Okay.
But maybe I'll ping you offline.
I just want to say that we are testing Copilot now to provide security suggestions so that you can fix code with less. Let's keep it here. That was a great question.
Cool. Well, thank you again so much, Joseph. Glad we were able to get through all those internet issues and appreciate you being here. Have a good one.
Thank you too. Have a good one.
Thanks.
All right. I think that brings us to the end, unfortunately.
At the end of the day? Already?
A little violin to play the sad music for us because I'm gonna have to part ways with you, Eric. I'm sorry. I've had enough of you.
Oh well, we're gonna see each other in person. Anybody out there that's going to be in Austin for Open Source Summit, come see Brian and I and a bunch of other people from our team out there. So be good to say hi. I think you already mentioned. Obviously, this is live streamed. This long video is available immediately, but they're going to carve this thing up and have all the individual sessions put out there by the end of the week. What else? What else do we need to cover before we?
Reminder for the nominations: go to DevSecCon.com community/awards to enter in your nominations for the individual. Excuse me, a little indigestion there. Inspiring individual from DevSecOps team and community members that you want to submit to those 3 different award categories that are there. In addition to that, yes, all the videos are going to get chopped up. Be sure if you're interested, right? We showed, I don't know if you still have that slide available, Eric, but I'll talk through this in the meantime. We have several chapters across the globe, 13 locations worldwide: Australia, Canada, France, Germany, Greece, Hungary, India, Netherlands, Switzerland, London, Virginia, US, Wales, and our global community for DevSecCon chapters. But if you're interested in getting started, creating your own chapter in your region of the world, or feel free to be part of those existing ones. But if you want to start a new one, you can find out more information about how to do that at DevSecCon.com. Last but not least, actually, no, not last. One more thing. If you want to keep in touch, I have conversations with folks in the community. The Discord is a great place to do that. It's a great tool to help you connect with other folks that are focused in this area, security practitioners, developers alike, all talking about and learning and leveling up their skills when it comes to developer security. If you want to be able to join in on there, the invite to that is also on DevSecCon.com. You can find that link. There's a big purple button that says join the community there, and that will bring you to the link for the invite for access to the Discord server. Now, last but not least, Eric, is we cannot leave and end things without saying a big thank you and shout out to the fine folks that helped put this event together for a full 24 hours long, right?
Yes.
And we got to let everybody know. In fact, I'm tempted to bring one of them on stream right now, but I don't know if they'll appreciate that. Let's see if they give me a little nod like, yes, that's okay, or no, it's not okay. Okay, no, all right. So, well, shout out to Sam, Carrie, Nina, Lynn, Nora. There you are.
Hey, there she is.
Thank you for everything that you all do. Crowd cheer.
And Nora and Carrie, who are in the green room.
Yes. All right, stop that. Wow, that's a really crazy crowd. All the folks that were helping behind the scenes too, that were helping with moderation in the chat, and just all the previous hosts and presenters. Thank you all so much for helping put on such a great event. And you all watching this, thank you for being here. Thank you for bringing up great questions. We hope you enjoyed it and you got a lot of value out of these amazing sessions, and we'll see you next time.
Bye, everybody.
Bye-bye. We got to close this out. Where's the button? Eric, what are you doing?